Hmm. All right. Maybe. Nope. Nope. There we go. Okay. Holy crap. That took way longer than it should have. Beautiful. All right. As it says in the title, what came before the Big Bang, the latest evidence? We're going to be looking at Alex O'Connor's semi latest video. I'm going to be reacting to it. I want to see what this is. I'll be honest, I don't know if Alex O'Connor should be stepping outside of his lane with all the science stuff. I mean, obviously, like he is a very kind of like famous atheist at this point, and I feel like the case for atheism is kind of just it has to be rooted in science. Otherwise, there's not really as much philosophical underpinning to it. Certainly, there's not nearly as much historical, arguments for it and against it. And the dialogue is much more constrained for atheism in terms of pure philosophy. You have to kind of get into some degree of scientism to underpin the sort of like the atheist movement. Certainly, the new atheist movement is very much rooted in materialism and science. But I don't know if Alex O'Connor is the best like science popularizer, science explainer. He's just not necessarily great at doing this stuff. That being said, he does have interesting guests on, and while it does sometimes become confusing because they're kind of talking at cross purposes, they're not really saying things to each other because they're speaking different languages, even if they're, like saying similar things. But that being said, I'm curious to see what this is about.
Welcome to the show.
Thanks. Great to be on.
Pleasure to be here.
What exactly is the Big Bang, Phil?
Well, people think they know, but actually there's quite a bit of controversy as to what we even mean by the term Big Bang.
Okay.
So we talk about two definitions, the hot Big Bang.
Interesting right away.
And that's just the idea that the universe evolved from a very hot, dense state. And then after that, it's expanded and expanded and it cooled, and then galaxies formed, and then planets formed.
Okay, so then I'm guessing this is like in counter to this sort of a Big Bang, as in there is like an explosion. There's an actual like moment of bang, as opposed to it was really hot and dense and it just expanded. Like there was no big giant like state change.
And us. But there's another definition of the Big Bang,
Okay, let's hear
which
it.
we might call the Big Bang singularity.
Ah,
That says that 14 billion years ago, time stopped ticking. This was the beginning of the universe.
yeah. This is definitely what I subscribe to. Now, my view on this as a non-physicist and have no bearing on this whatsoever. Actually, you know what? I might keep it to myself. I might actually keep this to myself because I think it's a really good. I think it actually explains a lot. And even though I have no scientific mathematical underpinnings to undergird this, I'm pretty sure I'm right.
So that's based off of theorems proven by Penrose and Hawking.
Yeah.
And what's interesting is that neither Penrose nor Hawking actually stood by those theorems. They actually think that some of the assumptions in the theorem don't hold in reality. And so maybe we shouldn't trust the idea that the Big Bang was the beginning. And in fact, Niayesh and I went to a large conference in Copenhagen. And
okay. Then I guess, well, yeah, okay. So the singularity stuff, I think the singularity is interesting. I think it's probably like the wrong word, because there is probably some specific like physics definition for it, and it's very specific and it means a certain thing, and therefore if you diverge from that, yeah, like I think the main point of like singularity versus hot Big Bang theory is like there's a moment of transformation. That would be my general like that would be the thing that I would be talking about. If we're talking about singularity, it doesn't necessarily mean time goes away. It doesn't necessarily mean, some of these other things happen, but there is a moment of transformation and change that's like significant versus no, it's just, it's just hot and dense, and it expands maybe violently, but there's no real like physical change.
Surveyed physicists. We asked them all sorts of controversies within the field, and in fact, the only one where we got a majority view was that the Big Bang should not be considered the beginning of time. Rather, it's a much more modest claim that the universe evolved from a hot, dense state and then expanded afterwards.
Interesting. And that hot, dense state that you're referring to is not the same thing as this singularity, right? When people imagine the Big Bang, almost by definition, it's the bang at the beginning. It's where everything got started. And so when you describe this hot, dense state, people might be imagining taking all of the matter and shoving it down to the size of an atom. But this hot, dense state is not that singularity that people imagine. This is sort of a little bit later on in the history of the universe, if there is such a thing as a singularity or whatever. This hot, dense state is slightly bigger.
The singularity is what would happen if you traced it back using certain assumptions. So we know that it was hotter and denser in the past, hotter and hotter, denser and denser as we trace it back. And if you take certain assumptions, as Penrose and Hawking did, then you get to this singular state where the density, in some versions, you might say the density goes to infinity. But the point is that the clock stopped ticking, and that's the beginning of time. But we don't have to assume that. And in fact, lots of cosmologists doubt that. They don't think the Big Bang was necessarily the beginning. But no one doubts that.
What assumptions would you have to make to assume that time stops at the moment, like before the Big Bang? I don't know. I mean, I feel like at that point you'd be probably looking into like the sort of space-time thing where it's like, okay, space and time are one thing. If you are going back and back and back and back, further and further and further, density becomes infinite, and therefore like space and time is then also like sort of negligible. Like they become zero at that point, and therefore time becomes like non-existent because it's infinitely small. So space becomes infinitely small, time becomes infinitely small, space-time becomes infinitely small, and therefore it stops. It doesn't exist. I guess I could see that, but yeah, I mean, that does seem sort of silly in the sort of general understanding of time. But granted, space-time's a weird physical thing, so who knows?
That there was some kind of Big Bang, and the hot, dense state is what everyone agrees on. But what came before that is the open question.
Interesting. The book, by the way, ladies and gentlemen, is Battle of the Big Bang. And the first question, of course, is going to be, what is it exactly that we're battling over? I think it's a great title for the book. We spoke about this when this book was in its sort of formation, and one of the working titles was What Banged? And this is a better title. Like this is going to sell more books.
Well done for the marketing team.
I think that's definitely the pro. But the reason I liked the title What Banged was because one of the great sort of questions for people who are scientifically minded, people who are religious, they'll say, oh yeah, sure, we've got this Big Bang stuff going on. But what we were really interested in is what made it bang, like what actually happened at the beginning. So it seems like when we're talking about the Big Bang, there's this question of this accepted theory of something near the beginning of the universe, maybe, that everyone agrees on, the Big Bang. But there's still this great mystery, well, what exactly was the Big Bang and what banged it and all of this kind of stuff. Yash, what is it about the Big Bang that we can know that isn't part of this mysterious, well, we don't know this, we don't know which model? What is it about the Big Bang that is this sort of uncontroversially accepted element of, early universe cosmology? And why can we be so confident about this hot, dense version of the Big Bang?
That's an excellent question. And before that, I was just looking at your hand, and it says this Big Bang, and you say there is one of the common myths about the Big Bang is that it was a point where things started, and Big Bang is in fact something that happened everywhere. So when you say Big Bang, you shouldn't do this. You do it like this. Is everywhere is Big Bang.
So how do you move your hands to do the Big Bang?
Everywhere. I don't know. I've never thought too hard about this. This is the Big Bang. I guess it's the Big Bang dance. Yeah, Big Bang. Yeah. So it's everywhere, and there is a bang. But let's get back to your question.
Yeah.
So what do we know about the Big Bang, and what don't we know about it?
This is a weird one. This is a weird. I mean, I'm going to let him talk for a minute, but when he says it's everywhere, that's true. But again, it's the idea that, space-time is compressed. So everywhere is the Big Bang. Sure, yeah. But I mean, to like an outside observer, I mean, I don't know. Because I mean, then you'd be like, all right, well, like, what the hell's outside of, the Big Bang? It's just insanely weird to conceptualize because it's like, all right, if it is all this super insanely dense stuff, space-time is super condensed in these types of things. So like, does that mean that all of space and time, like as far out as all the dimensions of the universe are right now in space and time and whatever other dimensions there are, if there are other dimensions, um, all of those things were there, like all of that, existed, but it was just like scrunched down. So like, if there were planets, they were like itty bitty, tiny, shrunken planets. And it's just very weird.
Talking about the Big Bang is kind of like talking about the sun, right? That's kind of uncontroversial. The sun is hot, right? We feel the heat from the sun. It must be hot, and then we can use a telescope. Of course, hopefully you shouldn't use a regular telescope. You need to put the right filter, otherwise you're going to lose your eyes. But you can look at the sun, and you could see it shines. There's a lot of light coming out of it. So based on the properties of the light, you can say that it's a hot surface. But what's inside the sun is a much harder question, and for that you have to rely on models and a lot of other things. The vibration of the sun, try to figure out what's going on inside of the sun. Big Bang is basically the same thing. We have very good evidence, incontrovertible evidence that there was something very hot that happened there. We're looking back. Now, the light we see is not quite the same as the light of the sun. It's colder. It's in microwave. In fact, it was, most people think it was discovered, this evidence for the Big Bang, the cosmic microwave background, in 1965 by people in Bell Labs, Penzias and Wilson. We point out that a little known fact, it was a Canadian, where I come from, who discovered this cosmic microwave background 25 years earlier.
Stolen
in the
valor.
40s. And so basically the same way that we see this heat from the sun, or we experience or see the light from the sun, there is a heat from the Big Bang that we get to feel. It's colder because Big Bang happened a long time ago and the universe has expanded since, so it's kind of cooled down that temperature. But nonetheless, we have detected it in various ways now. So there was this hot phase, and that's the thing that we know. And we can kind of go and probe the evidence of this hot phase the same way that we can look at the surface of the sun and look at the spectrum and say that there are these things that must have been in the sun. We can study the universe and learn about things that could have come out of that hot phase. But then what came before that hot phase? Was it a hotter phase? Maybe it was a colder phase. Those are parts that become kind of more speculative, because we're starting to kind of run out of good theories that could tell us what's might be happening. I mean, again, there's analogy with the sun. We've known the sun for millennia, since humans have been around. But what's inside the sun, it's actually pretty recent that we know what's going on, because for centuries we didn't know why the sun shines, and it wasn't until early 20th century that we discovered nuclear physics. I mean, all the other sorts of energy are just not efficient enough. The sun would run out of energy within like a few thousand years or a few million years. It wasn't until we discovered nuclear energy that we realized basically all the stars, including our sun, are nuclear reactors. And that was a missing bit of physics that kind of had bewildered physicists or astronomers for centuries. And when we found that missing bit of physics, then we could actually model the stars and the sun in particular. That for the Big Bang, we still have that missing piece of physics. And this is kind of the theme across our book, that the problem is gravity and quantum mechanics both become very strong as we approach the Big Bang. And we don't really have a unifying theory of quantum gravity. There are many proposals for this, right. But since we don't really have that theory, we cannot really come up with a good unified story.
And I do wonder about this. This is the kind of like the conflict. I don't remember which is which. I watched a really good video on this a little while ago, but it's been long enough that I've forgotten the specific terminology in physics about this, where it's like the difference between string theory and quantum gravity and these types of things. I feel like string theory is quantum gravity. Please let me know if I'm wrong about that. I don't remember exactly. I think it is. And I think there's a lot of stuff where it's like everybody's doing string theory. Everybody's doing, if it is quantum gravity, and there's just not enough movement forward in this. It's not predictable enough to basically be a good theory for, all this scientific research to go into it. It's just like it needs to be kind of like abandoned, or at the very least, shuttered. It needs to be, relegated to it's a good theory maybe, but we need to be branching out and doing other stuff.
Story the same way that we have for the sun. So the same way that we are waiting basic nuclear physics eventually solve the mystery of what happened at the core of the sun. That hasn't happened for the Big Bang yet, but that's where we're going, and that's what we're trying to do.
So we've got some good evidence for this hot, dense, early state of the universe.
Right.
And you've just mentioned this cosmic microwave background radiation, which many listeners might have heard of. And there's that wonderful story of Penzias and Wilson, who are sort of, I can't remember what it was they were actually doing when they kept getting this hissing. They were working at it was like a telecommunications.
Yeah, they were working for Bell Labs.
Yeah.
So yeah, they were a telecommunications company. In fact, there's an incredible irony here, because one idea for what might have come before the Big Bang is something called the Big Bounce. So there was a contracting universe and an expanding universe. And in fact, what was happening at Bell Labs early on in the early 60s was they were testing communication satellites. And there was a documentary made about what they were doing. And the name of the documentary was called The Big Bounce, because they were bouncing signals off satellites.
That's so fun. I love the way that these like myths and stories crop up in the history of cosmology. Not all of which are true, by the way. Like I have been telling people on this podcast for years that the term Big Bang was made up by Fred Hoyle to make fun of people who believed in this ridiculous but there's this idea that Fred Hoyle, who's one of the sort of opponents of this beginning of the universe view, is on a radio station and he goes, these guys believing in their Big Bang, and that's where the word comes from. Fred Hoyle did come up with the term, but it wasn't pejorative, right? If I
No, there's no evidence that it was pejorative. People assume it was pejorative, maybe because he was an opponent of the Big Bang. But what they forget is that he was also one of the main popularizers of science at the time, and he was trying to explain the rival theories to his audience in a way that could give some sort of metaphor, because he was on the radio, there's no visual aids. And in fact, Gamow, who was one of the proponents of the Big Bang, told his students that that Hoyle had used it pejoratively in a debate that they did on the BBC radio. But a historian of cosmology, Helga Krog, showed that there never was such a debate. He made it up. It just didn't happen.
Wow.
So that's where the myth of the
really
pejorative
made
term
it
comes
up
from. But there's just no evidence.
It's a shame. It's
hilarious.
such a good story as well, though, isn't it? It's always fun
That's even
when
better,
people
dude.
take on these labels. Another myth. Well, I say a myth. Another myth that you sort of hinted at just then, Nyesh, is the idea that Penzias and Wilson sort of geniusly discover this sought-after microwave background radiation. This is like, they call it the afterglow of the Big Bang.
Right.
The Big Bang happens and it leaves this pattern of heat all across the universe, which if the Big Bang occurred, we should still be able to detect today.
Yeah, that's right.
And so there were sort of people looking for it, and then Penzias and Wilson, geniuses as they are, discover it finally, prove the Big Bang, and win the Nobel Prize. It is true that they got the Nobel Prize, but they discovered it by accident.
Yep.
That's right.
Just up the road from people who were working on trying to find it, and were nearly there. Even though they found it by accident, they're the ones who got the Nobel Prize. And it had been detected earlier, just not recognized.
That's right.
So
there you go.
There's this incredible story of how all the evidence was sort of there, but it just took the right people to put it together. There's so much historical contingency involved in actually finding the right evidence in the right context.
And it's amazing how these kind of discoveries happen, because like often there are like so many pieces of evidence that are here and there and pop up, and in the hindsight you go back and say, oh, we inferred this from this and from that, but anytime, and I mean it happens over and over in the history of science.
E equals MC squared. It's such an obvious thing, and I don't want to say obvious, but it's so like elegant and it's so good and it's so like just it's such a good equation, and everyone recognizes that, you know what, this has to be the way the thing is, because the equation is so fantastic and elegant and it explains so much and it does it so well and it predicts so much. But the idea to come up with it is just mind-boggling. Like the person who actually put that together, Einstein, is just like, it's just crazy to think of. And you could model that out to like everything, like, Isaac Newton, all of these different things. It's just crazy to imagine the amount of like creativity that is necessary to make these things.
Is that when you're leading up to like a big discovery, there are all these bits and pieces that are there, but just people don't see it, and it just maybe takes a bit of luck. And in this case, Penzias and Wilson called up Bob Dickey at Princeton, who was a professor and has been looking for this basically for years. And he said, okay, we see this hissing thing. And then basically he said, oh, yeah, this is what we're looking for. That wasn't their intention. But it's amazing. And it tells, I think it's there's a broader lesson here, which is about the role of serendipity in discovery. So Bell Labs, for example, is a commercial company, right? They were trying to make communication and phones, but this Bell Labs was actually amazing. They did a lot of research, very fundamental research, and nowadays it doesn't happen very often. Like companies want to make money, and they don't really focus on fundamental science or just research and development as much. And it's really kind of reversed to the government, and we know what happens with the governments. Governments kind of their budget cuts and stuff. But yeah, so the question is, you do need this investment in serendipitous science, because you never know where these things are going to come from. Yeah. And these connections are random, but if there are enough of these triggers, eventually they're going to connect. And I mean, that's what happened for the CMB, that people were anticipating something, and then there was enough investment in direction of kind of advancing technology to find it. And then it eventually happened. And I mean, I'm amazed at what's going to be in the next discovery. It might be already in the making. There might be pieces and bits.
There is some real stuff for this. And I think, is it Brett or Eric Weinstein? I want to say it's Eric Weinstein, who speaks about this a lot, where he's like, look, man, we should be, I mean, it sounds horrible if you're opposed to this, but it's like, yeah, we should actually be going back to the era of the 17th, 18th, 19th century, where you had just super rich guys funding research because it was the cool trendy thing to do. Like Elon Musk and Jeff Bezos should just be setting up foundations for fundamental science because it's cool, because it's yeah, they want to be patrons. So instead of being patrons of the arts, you're patrons of the sciences. And that would it would be a lot better, because you're not funding these things based on who has tenure, and tenure only comes with certain professorships, and professorships only happen if there's we want a department, we want a string theory department. And okay, well, why do we have a string theory department? We have a string theory department because string theory is the cool new theory that everyone wants in their programs. So then we make a professorship around string theory because we want a whole bunch of string theory classes. And then you're okay, well, what if someone wants to do new research on this? And it's okay, was it popular? No. And I was all right, well, then you're not getting a professorship, you're not getting tenure, you're not getting any research done for this. So you need to basically pick one of the places that's popularized enough to potentially get a job in. Otherwise you're screwed. And that's not a way to do, this sort of revolutionary science. You're kind of pigeonholed into doing one thing. And especially if, that thing is very complicated, but also not necessarily actually being moved forward, sort of like string theory, you end up in a situation where you're not getting good, fun, lucky science breaks like this, because you're just not in an environment where that's possible.
That are here and there, people are seeing things they cannot quite connect the dots. But if there are enough of them, hopefully those connections will happen again.
But of course, the first...
And to speak more on the string theory stuff, it's that's the thing with string theories. Things have come out of string theory that have nothing to do with it, that are good, cool, mathematical models and these types of things that are good and predictive and applicable to other things, but they just have nothing to do with string theory. It's just lucky that you got this cool mathematical theorem out of string theory, even though what it was applying to, string theory, is, it doesn't work with that. So, the idea here is, we want to be, science should be more free and creative.
Evidence for the Big Bang we've had for thousands and thousands of years, since the writing of Genesis, of course, which predicted that the universe began to exist out of nothing, that God said, let there be light, ladies and gentlemen. And now we have this evidence that exactly that has occurred. In fact, it was a Catholic priest who is credited with sort of first maybe coming up with this idea of the Big Bang. I never like to pronounce his name, but it's something like George Lemaitre.
It's Lemaitre.
Lemaitre,
Yeah.
Lemaitre, with a bit of a phlegm in there somewhere. And he's a Catholic priest. And when he sort of theorizes this Big Bang, and when the evidence starts coming in, Pope Pius, the Pope of the Catholic Church, declares publicly that this is the evidence of the fiat lux, of the let there be light. So quite clearly, at the very least, we've got evidence pointing towards, even if it's just this sort of, at that time, just the cosmic background radiation later on and the universe's expansion and stuff, we're looking at evidence for the beginning of the universe, right?
Well, it's interesting you talk about Lemaitre because he was a very jovial chap, apparently, always in a good mood, except for that moment when the Pope declared the fiat lux and said, we're going to use the Big Bang to prove Genesis.
Yeah.
Lemaitre.
The very obvious and well-known, well-loved relationship between publicity and science. You get a science publication writing about your stuff. Hey, they wrote about my article in the New York Times. Oh, they screwed it up completely and they said I said stuff that I never said. Awesome. Thanks. I'm famous now, but for the wrong stuff.
Was very, very unhappy about that. Yeah. He wanted to keep his science and his religion absolutely separate. And he had a meeting with the Pope. Now, no one knows what was said at this meeting.
We know.
But the rumor is that he told the Pope, do not use the Big Bang as evidence of Genesis. This is a very bad idea. And in subsequent talks, Pope Pius never mentioned the Big Bang again. So I think it's good advice from Lemaitre not to use it. And actually, I was brought up Hebrew, so I actually know the Hebrew. And I don't think it's even been translated properly. I don't think it says in the beginning, God created the heavens and the earth. What I think it says is, and a lot of Hebrew scholars agree with me, is that when God began to create the land and the sky. And we know it's land and sky because the words in Hebrew, haaretz, means the land. I mean, lots of Jewish children will sing songs about the land of Israel, haaretz Israel. And Hashemayim is the sky, it's where the birds fly. So I don't think Genesis is in any way talking about the beginning of the universe as we know it. In fact, a lot of rabbis thought there was something before the creation. There was a chaotic state. And so when God moves over the face of the waters, this is a representation of the primordial chaos.
Right.
And it's
again, I mean, like, yeah, okay, dude, but if you're going to be talking in metaphors and stuff, oh yeah, there's this chaotic, it's the waters, that's chaos, it's primordial chaos. Okay, but then you can't be literal about it's the land and the sky. It's like, land means dirt, floor, and then sky means, the blue stuff above you. That's it. You can't be both metaphorical and super literal. Okay, you can be one or the other. It's clearly a metaphorical text more than it is trying to be literal. Okay.
It's very, very similar to the Babylonian myth, the Enuma Elish. And lots of people have drawn parallels to the Enuma Elish. So much more likely what's going on in Genesis is a sort of monotheistic repackaging of this ancient Babylonian myth. And indeed, in the Babylonian myth, there are sort of 7 tablets of creation. The gods rest at the end. They defeat the sea monster called Tiamat. And the face of the deep, the word deep in Hebrew, is something very, very similar to Tiamat. So I don't think there's any real description of the Big Bang in Genesis. And it doesn't really say that the universe had a beginning. It doesn't talk about a beginning of time. It doesn't say the universe came from nothing. And ironically, neither does the Big Bang say the universe came from nothing. It just says it came from a hot, dense state. So not only does the Big Bang not describe the universe from nothing, but neither does Genesis.
It's a great irony, isn't it? I mean, I did an episode a while back on the translation of this particular passage in Genesis. In the beginning, God creates the heavens and the earth, or when God created the heavens and the earth, or the land and the sky, he did this. And it's the difference between there sort of being this empty frame at the beginning of the cartoon. I had this guy called Magnify on my channel, and he sort of imagined it like a cartoon strip. In one interpretation, the first sort of square is like an empty box. That's the beginning. And then God creates. Whereas on this other interpretation, in that very first cartoon box, you've got God, you've got the primordial matter, and God sort of fashions it. And this is a great irony, isn't it? Because, like, you know, people think that Genesis says that there's a beginning of the universe.
Okay, yeah, sure. But I mean, again, like, then you can get into this and you can say, all right, well, what about the word create? What does the word create connote? Like, there is nothing, and then there's something. Like, creation. An act of creation is not necessarily an act of construction. It's not an act of, making, taking building blocks and putting them together. It can be something where it's like, I created this theory. This theory was nothing. There was nothing about it before, and then you create it, and so you create it out of nothing. And it's the creation nihilo. But then you can also be like, this again, it's just like, it's this weird, insane type of thing where you're taking a text that is charged with, metaphor and meaning, and looking down into the translation of a word that maybe was translated again, and you're saying, okay, create. Well, what does that mean in modern English? Well, we don't have a straight up definition of it that's actually like, perfectly universally workable. It's kind of like, it depends on context and this stuff. And it's like, all right, well, because of that, we're going to kind of crap on this story.
And the Big Bang proved it. But actually, translation-wise, maybe it doesn't.
Yeah.
And actually, if we're careful enough, maybe the Big Bang doesn't either. So when people hear the Big Bang, they're going to think we're talking about the beginning of the universe. That's what the Big Bang, like, is by definition, right? We'll get back to the show in just a moment. But first, do you trust the news? I don't. And a lot of we just talked about the...
I mean, it depends on what you mean by the universe. This universe? Yeah. I mean, that kind of is the whole point of it. Is that, the universe that exists as of right now, yeah, I mean, if you can't go back before the Big Bang, you can't make any kind of predictions about it, you can't make any kind of theories about it, you can't make anything, this type of thing. There is, like, there's a start point or a stop point, however you want to look at it, where in which you cannot go no further. Then you'd have to be like, okay, well, even if there is something before it, like the universe does exist before it, and we just can't figure it out, you would put a bunch of brackets on that and go like, okay, that was BC, this is AD. There's a significant difference between before the Big Bang and after it, such that the universe is in an entirely different state. So this is like the start of the universe, even if it's not necessarily the creation. It's the start of this universe.
These two different definitions. Yeah, why is the Big Bang maybe not the beginning of the universe? I thought that's kind of what the whole thing was about.
Right. So, of course, that, like many questions, that depends on what you mean by the beginning. So the Big Bang, in some sense, is the beginning of something. It is the beginning of where we start to understand how to describe universe, to talk about universe in the language that we can speak right now. So we have this hot, dense state, and then we can go back. And then at some point, kind of things become less and less clear, basically more and more fuzzy. So, I mean, the earliest we can use the laws of physics, and we have direct ways of kind of testing what we say about the Big Bang is maybe a minute or so after the so-called initial singularity. That's where the elements were formed, in particular hydrogen, helium, some lithium, deuterium. So these were forged at the Big Bang. Of course, they're forged in the stars as well, but primarily at the Big Bang. And going before that, we have ideas, but then we kind of going on a limb. We kind of take ideas and try to push them, extrapolate them to their logical conclusion, and that leads us to a point where if you push them, so it's kind of you're saying that this car is moving that way. Okay, so it's going to keep moving this way at, I don't know, 60 kilometers an hour. Maybe it's going to go that way for an hour. Maybe it's gonna stop in 1 minute and take a turn. You don't really know because you just know what it's doing now. And that's based on what we're saying. We could kind of extrapolate, but it's like extrapolation could be wrong because it could take a turn. And we're using the rules that we know to do this extrapolation, but the rules that we know kind of stop at some point.
This is like a backwards extrapolation.
Yeah, exactly.
Backwards,
like shrinking the universe down and down.
That's right.
Just assuming that keeps going.
Assuming that it keeps going, right? Assuming that it keeps going, it takes us to this point where kind of time stops ticking, and densities and pressures and temperatures could blow up, basically go to infinity. So that is what Penrose and Hawking back in the 60s called singularities, and
so
it was unavoidable according to those theorems. But those are based on assumptions, and we know that assumptions fail, and almost every practicing physicist thinks at least one of the assumptions that lead to singularities fail at some point.
So they think that there's this thing called the singularity,
and again, it's not even necessarily they think it fails. It's just that, okay, if that's the case, then it doesn't really, like, singularities are such a weird thing in physics that you kind of can't do them. It's like, like you go to infinity and it's like, okay, that almost certainly means that stuff's like wrong, because if stuff goes to infinity, you're kind of just like going, all right, well, I kind of just blew up my theory. I can't use it to, do anything anymore.
Which is also what's at the center of a black hole, famously.
That's right. That's right.
Penrose's work on singularities in a black hole that Hawking sort of cottons onto and says, hold on a second, if you take that singularity business and play it in reverse, you might get something like the Big Bang and singularity at the beginning of the universe. And this is a sort of reversing of time and an extrapolation, or whatever the opposite of an extrapolation is, towards the Big Bang. You just said that though relies on a few assumptions. What are some of the assumptions that this extrapolation relies on?
Excellent. So there are basically four assumptions that go in these singularity theorems, and these are, we kind of go over them in our book in a lot of detail. The first one is gravity is always attractive, which we think should be true. I mean, gravity, kind of its name, it says attractive, except that we now have incontrovertible evidence that gravity is not attractive on larger scales. We have this thing called dark energy, or cosmological constant. We've known that for basically almost 25 years now, that expansion of the universe is speeding up. So right now...
And then I think there's newer stuff, again, because there's always this pendulum swing. So like right now, I think the general popular science consensus is the big rip. The universe is expanding, it expands forever, and it expands because of dark energy. Dark energy pushes everything apart. Blah, 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 blah. Right? Okay. So that means that, eventually the end of the universe is going to come by everything that being pulled apart, even like, neutrons are pulled apart. And everything is, in a super cold, dense, empty, void state. But before that, like just before that, there's the big crunch where, okay, it expands, but then it contracts. It gets, everything, starts to crunch down again. And, we end up with like probably another Big Bang type scenario where we have this super dense, hot, small area of universe. And then it just keeps going until eventually it pops and, we get another Big Bang. That is, I just read an article relatively recently that said that's now kind of starting to be in vogue of physics, of like that's the new version of what's probably more probable in terms of the end of stuff. And it's casting doubt on the idea of, dark energy being constantly 100%, expansionist, pushing things apart at these large distances.
This very minute we're talking, on very large scales, gravity is not attractive, it's repulsive. So, of course, back in the 60s, they didn't know that. So they assumed gravity was attractive. That's assumption number one. Assumption number two is we have 3 dimensions of a space and 1 dimension of time.
Right.
That's, of course, everybody agrees there's 3 dimensions of the space. X, Y, Z can go up and down, left and right, front and back. And then there's time is ticking. But it doesn't have to be the case. And in fact, as we go in detail, many theories of gravity suggest that there might be extra dimensions.
Yeah.
Either the extra dimensions of space or time. So that's another possibility. Or maybe you could get rid of one space and add one time, or vice versa. Maybe you can no time and 4 spaces, etc. So assumption number 3 is that there are no time loops. Basically, time machines don't exist. And I mean, this is, of course, subject of basically indefinite fascinations, infinite fascinations, science fictions. Could there be time machines? Could there be not? And I mean, another chapter in our book that we go into is, yeah, there could be very plausible scientific scenarios where there are time machines.
That is a weird assumption.
Not all favorite science fiction movies may come true, but there could be some versions of time machines that exist. And assumption number 4, which at some level at the heart of basically any theorem, is that you need to assume some mathematics, basically. And the mathematics was mathematics of Einstein's theory of general relativity. But that also we know it has to break at some point, because quantum mechanics is this other theory, as I mentioned before, that we have, which is very successful. The reason you and I can talk, your viewers can actually watch us, is because engineers have used the rules of quantum mechanics to engineer basically technology for us to be able to communicate. So rules of quantum mechanics are very, very successful, happen to be inconsistent with mathematics of general relativity. So that needs to be revised as well. So these 4 assumptions, probably at least one of them, maybe all of them fail at some point. So this idea of kind of extrapolating back in time.
I do wonder why one of the assumptions is there's no time loops. You know? I mean, I feel like the sort of big crunch thing, a lot of people, I mean, it's like famously in an episode of Futurama where there's the big crunch and it turns out that, the universe just basically just restarts. So you have like that, but that's technically, I was like, all right, is that a time loop? Not really in the sort of time machine, conception, but I don't know.
That definitely fails. And that opens up kind of the door for all imaginative ideas that we still have to put in within straitjackets. So Feynman has this famous quote that science is imagination in straitjackets. So we are free to imagine things because there is no definite answer at that point. But still, what comes out of whatever we imagine should match our detailed observations of the Big Bang. Cosmic microwave background, distribution of galaxies, the geometry of the Big Bang, the sound waves that we measure coming out of the Big Bang. So these are all the things that whatever imaginative, creative thing you come up with has to explain.
And this is no joke, ladies and gentlemen. I mean, all of this talk about time loops and the Big Bang not being the beginning of everything. One thing that I love about this book is I don't know what you consider the genre of this book to be, whether you consider it to be, it's kind of a history in part. It's like an overview, almost like a survey. But what this book does, Battle of the Big Bang, should become clear to people now that the battle is for the model of what banged.
Keep showing.
And the great thing about the book is that you sort of remain agnostic. I mean, not personally agnostic, but the book is just exploring these ideas. And so if you're interested in this stuff, the book just sort of just goes over these ideas and says, look, here's an idea, take it or leave it. And that's why I love this so much, because it's one of those books that it doesn't profess to have an answer. So you just have to sort of go away and give it some thought. And one of the big questions is that throughout...
The best part about this is philosophers love that. Scientists tend to hate that. They're like, no, man. Like that kind of part of the profession is like, we need to be able to point in a direction. We need to be able to say something for real, seriously, and these types of things. Making these kind of like, I don't know, like here, I'm just throwing stuff out. A lot of scientists hate that. But philosophers love it because it is just like, oh, it's cool. There's all these new ideas I can think about.
All of these different models, and you talk about some 25 or so different models of what the Big Bang actually was and how it worked, is you actually got like a cheat sheet at the end, a big table of like, does it involve inflation, does it, and one of the columns in this table is, does this model say the universe has a beginning? And the majority of them say no.
That's right.
So hold on, like if the Big Bang is not the beginning of the universe, and if you've got this whole table which says here are like dozens of models of the Big Bang that don't say that the Big Bang is the beginning of the universe, then what is the Big Bang and what on earth came before it? I thought that talking about before the Big Bang didn't make any sense. It's like asking what's north of the North Pole.
That's right.
So what are we talking about?
Yeah, well, we're talking about not the beginning of the universe, but rather the end of our current theories, and what we need are better theories. So it might be that Einstein's theory of general relativity tells us the Big Bang was the beginning, but almost nobody in physics thinks that Einstein's theory of general relativity is applicable at the Big Bang. As in the IS shade, we need a theory of quantum gravity.
Is that because the Big Bang is so small? Or like, why is it that general relativity breaks down at the Big Bang?
So I wouldn't necessarily say the universe is small at the Big Bang. It could have been infinite at the Big Bang. It could be infinite now. We don't know how big the universe is. Rather, it was denser. That's the point. It was much denser and hotter in the past.
But not smaller.
So what's smaller is, if you like, what we would see. So our horizon, that's shrinking. So the observable universe,
we'd be shrunk too.
Is getting smaller.
But what does it mean to say that it might not have actually been small? I mean, again, like, it's difficult to imagine, right? But when I think of even just the Big Bang of the hot dense state, you know, forget the singularity.
And again, I mean, this is where it breaks
imagining in
down.
my head again. Here go my hands. You know, something sort of shrinking. Is that like the wrong way to be thinking about it?
So think of like
it's correct, but you also have to be thinking that the space inside of your, oh, everything's shrinking. Yes, that's true, but space is also shrinking. So, like, to somebody inside of the universe, inside of this ball that I'm shrinking, they are shrinking at the exact same rate that the entire universe is shrinking, and therefore, to them, the distance seems the same.
This room. Yeah. That's what you can see at the moment. I can't see what's outside this room.
Yeah.
So similarly, we can see out quite far, but nobody thinks the distances that we can see, billions of light years, is the whole universe. So that bit that we can see, you can think of that as shrinking.
So the observable universe was smaller at some point.
So I have another analogy for you, actually, which I think it's even mathematically reasonable, actually. So we know about black holes. You heard about black holes. Like, black holes have these horizons, right?
Yes.
That if you fall into them, you cannot get that event horizon of a black hole.
The point at which not even light can escape.
Not even light can escape, right? So if you're outside, in principle, you can shine a light, but if you fall inside of it, even if shine a flashlight, it cannot get out, right? Universe is actually, even today, the universe is like a black hole inside out. Right. So we have a horizon, but instead of we being outside the horizon, we're inside the horizon. So we are surrounded by it, and there's a point, basically, if you go beyond that, you cannot return. So we cannot see people beyond that horizon. And it's kind of like they're falling to the black hole, except that we are in the center, and the horizon surrounds us, is everywhere.
Whoa. Okay.
Yeah.
And is that to do with the expansion of the universe?
It has to do exactly. So the expansion of the universe is actually stretching everyone, it's pulling everyone apart, and at some point there is a point that they are being pulled apart in some sense faster than the speed of light, which you think like
that's super
it should
cool.
be impossible, but this is the thing. I cannot move faster than the speed of light relative to you, but the universe somehow can move faster than the speed of light. It's something that's like within the mathematics of general relativity itself.
Well,
you're not really...
yeah, I mean, so that stuff is basically just because, like, you can't move faster than the speed of light because the general relativity is, like, to accelerate past the speed of light is, I think, what most physicists would say. It's not that you can't move faster than the speed of light, it's that you can't accelerate faster. Because to accelerate up there, your mass goes infinite, and therefore it takes infinite energy to do it, and the universe doesn't have infinite energy within it. Probably not. But, you certainly can't, infinitize your mass and energy by accelerating up to the speed of light. But something that's already moving at the speed of light, like a tachyon or something like that, could exist. It's just that it was always moving faster than the speed of light. And the universe... or like, space-time, that kind of thing, what we're going to call the universe in this example, could be moving faster than the speed of light because it's not a particle. It doesn't have any mass in and of itself.
violating anything because there's no particle that's moving faster than the
Okay,
speed
he
of
made
light.
it.
It's the space itself that's moving faster.
You got it.
But then basically what it's doing is that, so those things are just kind of moving so fast that we cannot see them, and they're outside. So this, you can think of it as expansion of a space, or you could think of it as just like the way you think of a black hole, but inside out. And the distance to this horizon just gets smaller and smaller as you get closer and closer to the Big Bang. So a universe, so the space could be infinitely big. We don't know, but I mean, it's consistent with observation that the space is infinitely big. But the amount of a space that we can see up to the horizon, basically, the cosmological horizon, becomes smaller and smaller as you get to the Big Bang.
Yeah, as if we had like a huge sort of fabric, and I just took this little bit of the fabric and stretched out that bit of fabric.
That's right.
And that, like, within that bit of stretched fabric, you could see everything around you, like, flying apart, and think that all must have come together, but it could just be one tiny little ripple in a massive, massive fabric.
That's right.
I love this black hole inside out thing. That's really good to think about. And I think for people to understand, if the universe is expanding, it means, like, if something is expanding away from you, it means that the further something is away from you, the faster it's moving away relative to you, right?
That's
you can
right.
sort of imagine stood in the middle of a fabric, or the famous example of a cake, like a raisin cake or a chocolate chip cake. I know how much you hate raisins. Expanding, and like if you were in the middle of that cake, the raisins or the chocolate chips just next to you would be moving away slowly, and the ones at the very edges would be moving faster.
Right.
As the universe gets bigger and bigger, at the very edges, those chocolate chips are moving away so fast that if they're moving faster than the speed of light, or rather the space is moving, so that it has that effect. If that chocolate chip is moving away from you faster than the speed of light, then when light comes off that chocolate chip, it can't reach you.
That's
because
right.
the whole thing is moving away faster than the speed of light.
Absolutely.
It's kind of like,
that's cool.
A car driving away faster than the speed of sound. If you play a sound, that sound's never going to reach you because it's zooming off with the car. So you just reach the limit of our observation.
Yes.
Right? Like anything that's beyond that point, even if it's emitting the brightest light on Earth, it just doesn't have the time to reach us because it's all expanding away from us. And so
I think I should stop you there.
Okay.
I mean, as a student of relativity, I say you shouldn't compare sound and light and that extent, because in fact sound always travels with its medium, right? So so no matter how fast the car moves, the sound that comes to us basically is the speed of sound with respect to air, which is
whereas light just
light is independent of frame, right? So I mean, I think it would be true that if there's a sound and then moving, like you have a supersonic plane, then you may not hear basically because it's moving very fast than the speed of sound. But if the supersonic plane make a sound, we're gonna hear it. Because the sound is propagating with respect to.
Anyway, it's helpful to visualize. I mean, I guess if people are struggling to imagine this, imagine like a car moving at 10 kilometers per hour to the right.
Right.
And imagine that it emits, relative to the car, it emits like a particle that travels at 5 kilometers per hour in the opposite direction.
That's right.
Like, because the car is moving 10 kilometers that way and it's moving relative to the car, that particle will actually like be moving away from you, I guess.
That's right.
And so it would never actually reach you, even though it's been emitted from the car towards you. Because the overall movement is away, that particle goes away. And so light would function in a similar way, that the light would, relative to you, be traveling away and would never reach you. And so we just reached like the limits of our observation.
And this is the thing that I do find just always like confusing about physics when they're talking about this stuff. It's that they always say like the universe, but what they always mean usually is the observable universe. And I just think it's a very weird distinction that makes it super easy to get confused. Because it's like, all right, well, like when you say the universe, when they say the universe in terms of like the Big Bang, they mean the whole thing. I think, right? I think they mean the whole thing. The whole thing is in this giant, is in this tiny, hot, dense area. I guess we'll just say hot and dense, whatever. Not just the observable universe is this hot, dense thing. The observable universe is part of that hot, dense thing. And then the rest of the universe is also part of that hot, dense thing. But again, you then get into this thing where you go like, no, we're not talking about the universe, we're talking about the observable universe, is expanding past these types of things, and it's infinite and blah 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 blah. It gets so confusing.
Mhm.
And so, okay, maybe then the Big
Okay.
Bang is like a localized ripple in a larger fabric, but like, how can we begin exploring that question? If we're talking about, anything outside of the Big Bang being like, by definition, beyond our observational capacities, how can we even begin writing a book like The Battle of the Big Bang? Surely the only answer is we have absolutely no idea and can never have any idea.
Good. You were asking what is this book actually?
Yeah.
I just had an idea. You heard about the Schrodinger's cat. There's like a dead cat and a live cat. It could be the same. So this book is like a Schrodinger's book in the sense that it's a fiction book and a non-fiction book at the same time.
Adorable.
So we're trying to get to what's fiction, what myths about the Big Bang. And there's a lot of myths about the Big Bang. There's some that we talked about, but there's also myths that kind of cosmologists believe in and they think is supported by evidence or they think is proven. For example, there is a leading theory of the Big Bang known as inflation, which suggests that the universe was expanding very, very fast at a very, very tiny fraction of a second, was doubling basically every tiny fraction of a second, expanded by 30 orders of magnitude or so.
This is right near the beginning.
Right near the beginning. And this is... so this is an idea. Now, I'm going to tell...
As you explain that, what's the difference between... the Big Bang Theory as a whole is a big expansion at the beginning of the universe. So what's inflation as distinct from just the Big Bang expansion?
Very good. So... the difference is whether gravity is...
You could tell this guy, I'm assuming he's a professor. You can tell he's leaning on his professorship, and he seems like he could be a good professor. He's being so nice and kind.
Attractive or repulsive, right? So the expansion is expansion, but you remember I told you that right now the expansion is actually speeding up.
Yeah.
That it is expanding, but then it's actually getting faster and faster. So the gravity is even speeding up. So inflation suggests that something like that happened near the Big Bang, or in fact, just before the Big Bang, before the hot Big Bang.
Depending on the terminology, right?
Depending on the terminology, exactly.
Just to be clear, when you say before the Big Bang, if by the Big Bang we just mean the hot, dense state,
exactly,
then there could easily be something before. When you say before the Big Bang, people need to get rid of this idea that you're talking about before the singularity or before the point of creation. The Big Bang can just be used to describe this hot, dense state.
That's right.
Inflation is the idea that there is this like exponential speeding up kind of growth rather than just a sort of linear growth.
Yeah, exactly. So this repulsive gravity, the idea is that there was repulsive gravity much stronger than it is today, back then, before there was this hot, dense state of the Big Bang. And that kind of stretched the universe by 30 orders of magnitude. Basically, there are 100 doublings or so, basically. The universe doubled in size in a tiny fraction of a second. Many times. And because the reason it could do it was gravity was repulsive and very, very repulsive. And what it does is that it kind of takes a tiny speck where you could have like tiny quantum fluctuations in it, and it stretches it across the universe. So you get this very big universe, which is very uniform, the way we see it, with tiny fluctuations, which turn out to basically become these sound waves that we see that basically form, we see the ripples in the cosmic microwave background, and then eventually they form galaxies and stars and everything. So inflation is a leading theory, and many scientists, many cosmologists think it's proven, and we argue it's wrong.
Yeah.
In fact, there are many other leading scientists, like...
Because I'm pretty sure that inflationary theory actually, like when it says like it's uniform, the cosmic background radiation stuff is like not uniform, or I don't remember if it was cosmic background radiation, but it was something where it's like, the inflationary thing is not, it would mean that there is uniform something or other, and there's not. Maybe maybe it's the uniformity of like matter, like the way matter is like, situated throughout the universe. Again, when I say universe, I mean observable universe. That's the thing that's like, it's not totally uniform. There are like hot spots. There are places where it's, it's way more concentrated, and you wouldn't see that in like a pure inflationary model. Let's see if he says that.
Many we named, like Roger Penrose, who actually one of the originators of singularity theorems and won a Nobel Prize for them a few years ago. He thinks that inflation is not really a reasonable theory, and maybe we go over all other ideas. But here's the thing. So there are a lot of myths, and we try to go over them, and we discuss what evidence there is. But we also say that it's not really mythology what we're doing, right? Because there are very precise measurements, and there are many of them. There are dozens of them that we talk about. Again, this cosmic microwave background, we talked about its discovery, but in fact, what's the most amazing thing about it, and this kind of takes us back to Fred Hoyle, because Fred Hoyle named Big Bang, but he was a critic, I mean, pejoratively or not, he was a critic of Big Bang. But I think inadvertently, he maybe gave a very good name to this theory we talk about, because bang, when you think about bang, is something loud. And our best evidence for what happened at the Big Bang is the sound waves. We cannot quite hear it with our ears, but there are ripples, variations in the cosmic microwave background that were just the sound waves, the primordial sound waves that must have been created at the Big Bang or before the Big Bang by whatever that happened there. And these properties of these sound waves are measured very precisely now. How big they are, how they change on wavelength or depend on wavelength. Now they're stretched on millions or billions of light years, so they're very, very much bigger than much longer sound.
Okay. Maybe he's using different terminology. Maybe he's not. Maybe I'm not. I don't know what he's talking about here. But when he's talking about sound waves, didn't he just say like they're propagating through a medium? There's no medium in space, is there? It's a void.
Wavelength and the sound waves we used to communicate right now. But they are there, and they're measured very precisely. And any speculative, weird time travel idea you come up with has to explain them, right? And that's kind of that's why
these are sound waves that we measure now.
These are sound waves that. Well, we measure them now because we exist now, but it's kind of, we measure them indirectly because, so what happened was they were propagating across the universe, but at some point, universe becomes basically low density, so sound waves kind of freeze.
Yeah, because people want to know, like, how can sound waves travel across the universe if the universe is this sort of vacuum? You need air to travel.
Good. Yeah. Yes. So, I mean, universe is not empty. There's matter in the universe, right? And it was dense at the early time. So you had this primordial plasma that's very high density. So sound waves could propagate in it.
Okay, primordial plasma. And this is like a state of matter.
Like a soup.
Yeah.
Similar to the surface of the sun.
Exactly.
Right? This kind of state where when everything's dense enough,
right,
it's the kind of thing that sound could propagate through, like throughout the whole universe, because the whole universe is like plasma.
I mean, I totally
and I guess we say sound. I guess we say sound, and like we would hear it because it's a thing, but it's like sound. The way we're thinking about it is literally just like a wave propagating through matter. It's not necessarily like, I don't know how to describe it, other than a sound, which is why they call it a sound. But it's, it's not like bing. It's more of, the air moving.
It's like a black hole inside out. I mean, the Big Bang, it's kind of like a star inside out. I mean, I guess an empty universe is like a black hole inside out. But if you have matter and Big Bang, so Big Bang is like a star inside out, like a sun inside. So we can see the surface, right? And in fact, literally, it's the same analogy, right? So we can see the surface of the sun. We cannot see inside the sun, right? And the same as with Big Bang. We can see this thing called the last scattering surface, which is kind of the surface of the Big Bang. It's where light the density is low enough so light can propagate to us. But then beyond that, light cannot propagate directly, but sound waves can. And in fact, that's exactly the same way we can probe what's inside the sun. Of course, we have our mathematical models, but there are also sunquakes. It's called like helioseismology is a sign. So because sun is kind of very active, you could, if there are solar flares, in fact, Phil is very good at imaging all sorts of sun-related things and auroras, and then the pictures of the various.
Phil's own images appear in the middle of the book, and I must put a link to your what is it, your Flickr account or whatever. Phil is also a phenomenally talented like space photographer. It's like
Right.
I was blown away the first time I saw it. So I'll try to remember to put that in the description as well. So yeah, but
Yeah.
the sun.
The sun, yes, the sun is a very active place, and there are all various activity that happens. But in particular, basically, there are waves that propagate in the sun, and by mapping these waves on the surface of the sun, so these are sound waves, and also there are gravity waves. There are different types of waves. By mapping these sound waves, you could actually map what's inside the structure inside the sun all the way down to the core of the sun, which is also kind of how we know what's inside the Earth, because I mean, the Earth, there are also earthquakes, and by mapping those, because
So we're looking at the effects on the surface, the sound waves, the gravity waves, and from that we're seeing what's in the center.
That's right.
And the Big Bang is like a star in reverse.
Exactly. And that's what we do with the Big Bang. We see the surface of the Big Bang is inside instead of outside, so it's kind of inside out, but it's still we can see the ripples on the surface.
Yeah, we're looking at the surface from the inside.
Exactly.
Yeah, we're looking at that's interesting.
Yeah,
It's the same kind of process.
It's the same idea, and those sound waves can go much deeper inside. And then there's something even more exciting. In fact, I mean, for the sun, there was something like that was a big breakthrough. There were neutrinos. This is another type of particles. It's kind of complementary to the sun. So neutrinos are these weakly coupled particles that are made at the fusion in the center of the sun. And we eventually detected them. We've been detecting them for a few decades, but they weren't quite matching until we detected all different types of neutrinos. So the key is that you want something that kind of can freely propagate in a space. For the Big Bang, there are neutrinos. They're just very hard to see, so we haven't quite cracked that nut yet. But there's also something possible, which is called gravitational waves. So these are ripples or fluctuations, basically waves in geometry. So even if there's nothing, that you could have geometry of a space according to Einstein's theory of relativity, which could ripple and wave. And those could have been emitted from the Big Bang. And there are many theories. Some of the theories of the Big Bang predict that these waves are there as well. And there are many experiments that are looking, and we have been actively looking for those. So these are all the things that can come out of, we can detect directly or indirectly from the very, very early moments, well beyond what we've seen today. And they can kind of probe these various speculative ideas and rule some of them out. And this is why it's not all fiction. There is some non-fiction in it as well.
Yeah. Phil, why is inflation an important idea? Why do so many scientists believe in it? And why are you suspicious of it? And I mean, particularly the way that we've just described inflation is the inflating of the early universe. And a lot of people will listen to that and go like, okay, I thought we knew that already. You know, the Big Bang, the universe expands. You might say, no, inflation says that it's speeding up. It's like, well, I thought we kind of knew that already anyway. You know, everyone knows the universe is expanding, and kind of who cares? Like, okay, it's faster. So,
like what's the importance
of this inflation idea?
Well, I think there's two reasons why it's so profound, if it's true. We can go over reasons why it might be true and reasons why it might not be true. But let's go to the implications. One, as we said, inflation is a pre-Big Bang model. It happens before the Big Bang. So if we can confirm inflation is true, then we can tell what happened before the Big Bang.
What does that mean? Like, so what is it that's inflating?
Okay, so it's the space that's inflating.
Yeah.
And so this is before the hot dense state.
Yes, before the hot dense state.
So what are we talking about here? So help us to visualize this.
Just imagine empty space, but it's filled with a field maybe that will push the universe to accelerate in its expansion. So,
but this is not hot and dense.
No. It would be as cold as it could be. And then when inflation ends, all the energy in that inflating space actually is converted into matter and radiation. Then you have the Big Bang.
Then it's hot.
So the Big Bang is what happens after inflation. Whereas a lot of textbooks will tell you it's Big Bang then inflation. But even I interviewed Alan Guth, who invented inflation, and he calls it a prequel to the Big Bang. So
inflation, big, like sort of exponential increase in the size of space. Am I allowed to say that?
You can, but remember the caveats that we said before. Yeah.
And then inflation for some reason stops.
Yeah, because it's supposed to be unstable, so it decays, and this is the next most important implication.
And then energy, the energy of that expanding space turns into matter and radiation, and that matter and radiation is the Bang.
Is the Bang? Yes,
I got
absolutely.
All right.
Yeah.
Yeah. So think about it like we're moving it apart. It's like the friction of space expanding creates matter because it's such an energetic, insanely, giant ripping of space. The space itself, the friction of it moving so quickly creates, matter and energy and these types of things. It wouldn't necessarily be friction, but you can think about it like that.
Here's the other super profound implication of inflation. While this inflating in space is decaying, it's also expanding exponentially. So you could imagine it like a radioactive particle decays with a half-life. So imagine one bit decays, that's our Big Bang, that's our universe. But think about the bit that's not decayed yet. What is it doing? Well, it's exponentially expanding. So what happens is the volume of inflating space cannot go down. As long as the exponential expansion is faster than the decay, then the volume of inflating space will just go on increasing forever. So then at the next half-life, you'll get another Big Bang. Then it expands again, or the bit that hasn't decayed, it keeps expanding.
There you
so
go.
you get another Big Bang. So analogy I use is Sunday afternoon when I go to my mum's house and she makes this fantastic chocolate cake. It's really yummy. And she puts the cake down and we all have a slice and half the cake is gone. Then a little bit later, we go back for seconds. The whole cake's gone. You can't have your cake and eat it.
Yes.
But imagine if the cake was doubling in size very, very rapidly. Then we went back for more cake and the cake has got bigger. So now we just have the same slices of cake that we had before and we could just keep going forever.
So in this analogy, what is the cake? What is the thing that's getting bigger and bigger?
It's the space, the inflating space.
The inflating space. And our universe is not that inflating space.
No, it's what came when that inflating space decayed into matter and radiation.
But so
Gotcha.
help me picture this,
So it's
right?
not-
So we've got inflating space. This is inflation. You've got space sort of getting bigger,
Yeah.
and then inflation stops.
In our patch.
But so so you've got this sort of big inflating space,
Yeah.
and it's just a little patch of that inflating space that stops inflating,
Yes.
which causes this boom,
Yeah.
like energy, matter, all this kind of stuff.
Yeah.
But the whole thing is still expanding,
Mhm.
and
The
so
rest of it is.
that little miniature part
Yeah.
is expanding locally as well.
Yes.
But outside of that,
It's expanding even faster.
and there might be other patches
Yes.
that keep stopping and slowing
Yeah.
because inflation
would
is
be.
unstable.
Yeah.
And so there are little patches where it stops, and that's vroom, 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 vroom,
Yeah.
vroom, big,
Yeah.
big bang, big bang, big bang, maybe
Yeah.
little bang.
Yeah, that's
medium-sized
what
bang.
most inflationary cosmologists
Okay,
suggest.
so
yeah.
does that
So-
mean that this inflationary idea points to a multiverse?
Yes.
Is that what we're talking about?
That is where the idea of a multiverse
Yeah.
comes from. I mean, there's another view from quantum mechanics,
Yeah,
but that's
there-
generally considered quite separate.
Yeah, sure.
Yeah.
But this idea of
The quantum one is the one most people think of multiverse. That is the vast majority of people are thinking of the multiverse stuff. When most people talk about multiverse, it's not just, okay, there are observable universes. There's big giant, there's tons of little observable universes in this space. It's that, there are multiverses, they're quantum, branches and these types of things. But the idea of, probabilistically speaking, if there is this, expansionist inflationary thing and there are multiple universes popping up, well, if that keeps going forever, you're going to have every possible combination of, universal, atoms and waves and particles and blah, 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 and every possible combination ever. So that if you could travel to these other universes within this multiverse, then you could get, a world in which where, I don't know, like FDR loses in the first thing and blah, blah, whatever, Germany wins World War II and there's an alternate history and these types of things.
the multiverse is coming from inflationary cosmology, and that is quite mainstream.
I'm often told that the only reason people believe in the multiverse is as a way to get out of like the fine-tuning argument for the existence of God. In other words, like the multiverse, like we can't say it's false, it's ridiculous, and we're not going to say it's ridiculous, but there's no evidence for the multiverse. It's essentially like a philosophical tool that people use in religious arguments.
No.
But not the case?
No, definitely not the case. I mean, it was a discovery. It wasn't. Someone didn't look at the fine-tuning argument and say, well, let's have a multiverse. No, what happened was they were looking at inflationary cosmology, and then it was actually Nia Esh's colleague at Princeton who was one of the first to realize that inflation would make a multiverse. This is Richard Gott. He's also the master of time travel. He's an expert on time travel and lots of things. So he was one of the first to say inflation would just make a multiverse. But at first it was thought, well, these are sort of curious solutions to inflation. They didn't really take it very seriously. Then another scientist came along called Alex Valenkin and Andre Linde as well, and they showed that this was a generic property of inflation.
Mm-hmm.
So Alan Guth, there are actually lots of different inflationary models, but what Guth says, he's the creator of inflation, is that almost all models of inflation are eternal. So they will make a multiverse. So independent of any argument about fine-tuning, we have an argument for a multiverse coming from inflation. So if you take inflation seriously, then it looks like it generates a multiverse. Now, there are one or two cosmologists, Slava Mukhanov's one, that don't agree with this, but I think I've interviewed a lot of the people that worked on inflation. I would say that's a consensus view, that if you have inflation, then you have a multiverse. And then we can ask, is there evidence for a multiverse? And that depends on your view on whether there's evidence for inflation, because a lot of cosmologists say there is evidence for inflation. In fact, they think it's very strong evidence. Some people say it's been proven. And what we argue in the book is, well, there's good arguments back and forth about this. You can say, you know, inflation made lots of predictions, but then you can challenge that and say, well, maybe that's a dubious statement. So, I mean, I think Niash is more in the anti-inflation camp, whereas I change my mind like every other day about this. Sometimes I think the inflation is really strongly supported, and others times I'm with it.
I think Phil has to be very diplomatic because he interviews all people. So I can be more strongly worded. But in the book, we try to find a common voice so that no one gets offended.
Sure. To be clear, Alan Guth is not the creator of inflation. He is.
No, he is.
He's the guy that came up with the idea, but he's not the man who
he came up with the idea.
Who created the inflationary universe.
Well, we do talk about whether it's possible to make a universe in a lab.
That's the other thing, right?
And Alan Guth is one of the scientists who suggested that it might actually be possible.
Okay, look, I want to talk about that.
Yeah.
But also, I want to take a moment, because like you guys have been writing about this for it must have been years now, like on this particular book, and before that a long time. The series you're referring to, Before the Big Bang, which is on YouTube, it's on your channel, Phil, which I'll also make sure is in the description if people want sort of a documentary version.
Did he make it in the description?
And you're so wrapped up in it, I think, that when you're talking about these models and inflation and stuff, it's exciting, but we've got to take a step back and realize that people are listening to this with no idea what we're talking about, right? So they're like, okay, so let me get this straight. There's this idea of like the Big Bang. Okay, the terminology we should use is that the Big Bang is whatever the hot, dense state is at the beginning of like our observable universe. There may have been some stuff existing before that. This sort of like empty space that is expanding. And expanding in such a way that there are little local patches of, you know, creations of like mini universes everywhere. There are going to be a few questions that come to mind. Firstly, so what is this like thing that's expanding? What is this empty space? It can't be empty if stuff is like coming out of nothing. You know, there's got to be something there that's expanding. Secondly, we talked about like inflation stopping because it's unstable. Not really sure what that means, but the thing that really gets me is like, okay, there's empty space and it's expanding, and then it stops, and then vroom, like matter and energy, just like what, out of nothing, out of nowhere, like, you know what I mean? Can we take a step back now that people understand what we're talking about? This big sort of space that expands exponentially, potentially, and little pockets of instability, and so, like, people are going to be like, but what is this? What are we talking about? How does this matter and radiation spring up? Like, where are we? Where's this coming from? You know what I mean?
So imagine like a pool table. Okay. But imagine like there's a hole like in the middle somewhere, right? And so imagine there's no friction. Okay, sorry, I should not imagine too much. Okay, so imagine there's no friction. So they're like kind of imagine you can hit the pool a ball and it just keeps bumping left and right and it's all over the place, right? So that's kind of like a quantum C, or if you want. So that's the pool table is your inflation, like the universe somewhere in there. Every now and then it may come across this tiny hole and fall into it, and then that's where it ends, right? But it's the thing is that this ball doing different. I mean, the state of the space doing different things in different places. They don't talk to each other. It's an infinite universe, right? So some places in the universe, this ball may fall into the hole, and that's where you get a Big Bang. And then you can kind of see when the ball falls, then it's kind of you make it hits up, right? So that's, I mean, that again is an analogy. You shouldn't take it too seriously. But what you're doing is that there is energy in empty space, right? And this is the important thing: is repulsive gravity is not such a strange thing. In fact, any kind of energy that you associate with empty space is going to give you repulsive gravity. And the simplest model for dark energy we have now is energy of empty space, the so-called vacuum energy. And it could have been the same with the inflation. It's just that a much heavier empty space. The vacuum energy during inflation would have been much higher because of a much faster expansion, much faster repulsion, or much stronger repulsion. But still, what happens is that so universe is basically is inflating. This is your pool table. Anywhere in there, there is this huge vacuum energy, and universe. I mean. You think it's vacuum, nothing is happening, but vacuum in quantum mechanics is actually a very vibrant place. There's a lot of fluctuations that are happening. Things are moving around. So, I mean, the ball in the pool table moving around is like a classical thing. But really, I mean, all the fields in a space are vibrating like very violently in quantum mechanics, basically.
So this empty space is this sort of ocean of quantum fluctuations.
Right, exactly. And that's everywhere, right? But the thing is, the instability, the idea of instability is that it could be, and it doesn't have to be, but I mean, for Big Bang to happen, there needs to be an instability. There needs to be a hole somewhere where inflation needs to end. So your big pool table, so if your ball, which is kind of the state of your space, or your field, if you want, it's called fields, I guess, instead of billiard balls, we call them fields in physics. So if your fields come across this hole, they may fall into it, and that's where kind of they heat up, and then you create matter and radiation and stuff. But this is something that happens kind of randomly, stochastically, and it doesn't have to happen everywhere because it just is a random fluctuation. In some places it happens. Those places you make a pocket universe, and we happen to live in one of those pocket universes because we cannot live anywhere else. Like in this vast sea on the billiard table, there's nothing there. There's just vacuum, right? So we need matter and radiation and kind of we need fluctuations to actually grow. We cannot live in vacuum.
Okay, so this empty space that's expanding at inflation is not truly empty in the sense that it contains sort of quantum fluctuations.
That's right.
And some of these fluctuations sort of pop matter and energy into
That's
existence.
right. Yeah.
Okay. Inflation then, I'm imagining before our Big Bang, we've got this space that's growing. Does that mean that if I play that in reverse, that empty space of quantum fluctuations and stuff would shrink, meaning that eventually we still have to get back to this like singular point from which everything expands? It's just now instead of talking about our universe, we're talking about this empty space of quantum fluctuations, which is not actually nothing.
Right.
Phil?
Well, okay, so...
Okay, yeah. Can't be that simple.
Question. So inflation is often called eternal inflation because once it starts, it can never stop. It will make universe after universe after universe. Now there's a question, okay, it's future eternal, but is it past eternal?
Yeah.
Can it just go back forever?
Right.
Remember Niayesh said that one of the assumptions of the singularity theorem that proved the beginning of time was that gravity is always attractive. Now we're talking about repulsive gravity, so we violate the Penrose-Hawking theorem that proved the Big Bang was the beginning. So maybe we don't need a beginning anymore. Maybe inflation is past eternal as well.
But surely something is, if we're thinking about going backwards in time, if something is shrinking.
But remember, the whole universe could be infinitely big. Right. So when we said shrinking, it was only a particular patch that we're concerned of. You know, the equivalent of us in this room, of what we're
inflation is not like a thing that happened and it's now over and done with. The idea is that inflation is like the status quo. That is like that is just what's going on.
The majority in this scenario, the majority of the universe is inflating,
and that never ends. It's just inflating, which is exponential growth.
The universe is not,
and that just keeps going forever. And maybe it's past eternal.
So that's the debate: is it past?
And little universes sort of pop up here and there.
People often quote a theorem by Borda, Guth, and Vilenkin.
This seems more likely.
Says that inflation cannot be past eternal. However, other scientists have said actually it can be past eternal. That they made mistakes in their mathematics, or they made some assumptions. And so maybe it can be past eternal. And obviously we can't tell. There are claims that inflation is verified empirically, and we can debate those claims. Is that true? Is that false? But nobody would claim that we could empirically check whether inflation is eternal into the past or not. That's something only we can investigate through theory. And unfortunately, theorists don't agree about this. So we don't know whether inflation would be past eternal or not. But, if you believe Border Guth-Vilenkin, then actually inflation would have a beginning. So then you could ask, okay, well, what happened before inflation?
And what would that question look like? Because now we're not looking at this hot, dense, Big Bang matter energy. We're talking about the beginning of inflation, which, as far as I understand, is something which applies to this quantum soup, for lack of a better word, and that would therefore have some kind of beginning. Like, I don't know, man. Like, is there time in this?
Yeah, that's the real question.
Quantum soup, because I thought that time was like a
That's the
dimension of
correct
space.
Yeah,
and if space is part of our universe, like, does that apply outside of it? Like, I'm struggling to like visualize it. I'm visualizing almost this like fabric expanding. It's a bunch of like lines going through space that's growing and growing and growing. And it's full of quantum fluctuations. Does time pass in this inflationary universe, for example?
Okay. No.
Yep.
It sounds that there is an. These all sound very mind-boggling and science fiction-y. But in fact, the physics of inflation is like the most conservative kind of physics you can find. So there is time, there is a space, there is energy. Everything kind of works in the way that Einstein thought it would 100 years ago or so. Now, there are quantum fluctuations as well. Quantum fluctuations, I guess famously, Einstein said that God doesn't play dice. So you had like a mixed relationship, let's say conflicting relationship with quantum
that's
mechanics.
a famous quote. Einstein saying God doesn't play dice with the universe. I only found out from your book that Niels Bohr, responds by saying Einstein stopped telling God what to do.
That's true. Yep, indeed. But these are all like 100-year-old ideas. You're just kind of pushing them to the extremes, and I think that's what gives you this idea of multiverse and time inflation. So in fact, these are not the most radical things we discuss. This is the most conservative thing we discuss in the book. It's as mind-boggling as this sounds.
Because I would think that theory would work better if you were to say like, in this like inflationary space, this whatever we're going to call it, this quantum state, void, there is no time. I would think it would work better. I guess philosophically, not necessarily physically, but I feel like it works better there because that way it is past eternal, future eternal, because there's no such thing as time. So it's all contemporaneous.
It's basically just saying that, yes, early times, there was this huge vacuum energy, but vacuum energy, again, it's something, as a standard quantum theory can give you a vacuum energy. Now, may not give you the right amount of vacuum energy, but can give you a vacuum energy. It just say you had a big vacuum energy early on, and there are fluctuations around it. There's regular time, regular space, so I think everything works in the most conservative way possible in eternal inflation. It's just a very weird, different place because we are pushing the laws that we know to the extremes that are very unfamiliar to us or unfamiliar to the universe as we know it today, right? But the more mind-boggling things are, for example, if the entire space, time didn't exist at some point, and that's a separate scenario. For example, Hartley and Hawking proposed that maybe inflation was not eternal. It actually started, maybe time has started at some point. And it's actually, very, very reasonable point is that because
time as we're kind of perceiving it, not necessarily like, like time in this universe as like space-time.
We know we want a theory of quantum gravity. We know quantum mechanics and gravity. At some point, they're going to come to head.
Maybe.
So what does it mean and how does it look like? And one way it may look like is that maybe at some point, time, which is essential part of theory of relativity, because relativity is a theory of space and time. Maybe time doesn't exist at some point. At that point, at this time in the classical sense that we know. So I think the analogy I like that Phil uses is like the wetness of water, right? So we all are familiar with wetness of water. But if time is like wetness of water, that fundamentally doesn't mean anything, because the water, if you could look at it with a very powerful microscope, is just made out of molecules, right? There is no fundamental concept of it. It's just an emergent concept. So what if time itself is an emergent concept? And right now there is a reasonable definition of time, but if you go back at some point, that just ceases to exist.
What does it mean to say that there is, like, time begins at some point? Like, it seems to me that in order to say at some point, you need to sort of place it on a timeline.
Right.
If you're talking about the beginning of time itself.
Right.
Like, what could that even mean? I mean, trying to place the beginning of time at a point in time.
Right.
It's like trying to trying to place the
It
origin
is
of all
insane,
matter
but
in a particular location or
I don't
something.
have a
You
huge
know what I mean?
problem with it.
Like, what could it mean? Say the
Well,
beginning.
I mean,
of
I
time?
think you could be try to be precise about it,
Mhm.
but I mean, you can say, okay, so when you're asleep and awake, right?
Mhm.
So where is the exact point where you go from being asleep to being awake? And I think it's I mean, we could try to define it more precisely if we have a precise theory, but it kind of tells you that, I mean, if you think about it, we have experiences, and in physics is the same. I mean, everyday experiences, we don't necessarily quantify it when we are asleep or we are awake. I mean, I suppose physicians can quantify it, like take our pulse and say, okay, so this is asleep, this is this exact point is where someone falls asleep. But that's not really the
It's
point.
arbitrary.
The point is that we have an approximate description of something, and that approximate description might be good, like when now you and I are talking, but at some point that approximate description, the way I understand the word, gets kind of more and more fuzzy, right?
But my issue isn't trying to figure out like when time began. My issue is just with the concept as a whole, right? Because if I imagine that there's a point, if we go back and back and back, there's a point at which, you know, time stops, time doesn't exist anymore.
Right.
I'm sort of imagining being at that point where there's no time. If there's like no time, like that means sort of we're existing timelessly. How can we then say, okay, there's no time, no time is passing, and then at some point, time starts? You know, surely if it's timeless and the universe doesn't exist yet, and it's timeless, then the universe has to timelessly not exist. Now, how do you get this beginning of time at a point in time? You get what I'm saying?
Well, one definition of time, I don't know if Neil Ashe agrees with this, but one definition of time that one physicist said to me was that it's a correlation between events. So if you don't have correlations between events, there's no time. But that doesn't mean there's nothing happening. So things could be happening even if there's no time, because there's no correlation between events. You can't make a clock.
This will depend on your theory of time, right? So people are probably broadly familiar with the A and the B theory of time. I spoke to Emily Cressy-Hurst on the show the other day, who helped to introduce me to the concept of the C theory of time, which, if the A theory of time is that time really passes and the past doesn't exist anymore and the future doesn't exist yet, and the B theory of time is the block universe where the past and the future all exist, and, you know, we're sort of somehow privileging a particular moment, but the past exists and the future does too. The C theory of time is that, like, there is just the relation of events, you know, and there's no direction of time. And she sort of said, like, you know, to have time, you just need to know that you have like World War II and you have like this podcast, and they are like related to each other. There's no sense in which there's an objective direction. There are just relation of events. The only thing that matters is that they're in the right order. So it doesn't matter that, like, you don't need to say that one comes after the other, but you can't put the death of Queen Elizabeth like outside of that. That has to go in between them, but time sort of isn't passing in the traditional sense. Okay, so we've got this like relation of events as being just the nature of what time is. So if people are struggling to imagine, like, you know, they're sort of thinking, well, how can there be a beginning of time? That doesn't make any sense. It's like, just try to think about the concept of time now when it does exist. Try to define it. Try to understand what it is and how it works and what it means.
There you go.
That is confusing enough. So, like, I do think it's like a really difficult challenge to be thinking about the beginning of time. But maybe that's just a property of the weirdness of time as a whole. But okay, so maybe time.
The way I would put it is essentially that when we say time, we're talking about time in the observable universe, and therefore we're kind of talking about, again, we're talking about this in terms of physics. We're not talking about it in terms of, you know, the philosophical ABC time definitions. We're talking about it in terms of physics, and in terms of physics, we're talking about space-time, basically, in a lot of ways. We're talking about it as a you know, specific kind of like, you know, measurable thing that's, you know, a part of the fabric of this observable universe. And therefore, outside of that, time is not necessarily, you know, like if time doesn't exist, it's not necessarily true that, you know, events, you know, don't happen, because it's like timeless. It's like, okay, well, you can have it like timeless in the sense of, you know, eternal and unchanging because it's timeless. There's no events. There's no relationship between them. It's just that you've got something that is basically, like everything is happening at the same point. Everything happens, infinitely, eternally, and also, at exactly the same point. And therefore, you could have, the sparks fly off, and you've got the inflationary universe, boom, and then you've got space time, boom, and then it's got, this linear time that we're seeing now. That'd be I mean, again, I'd like to talk to someone who'd actually be able to tell me I'm an idiot, but as of right now, that's what I'm going with.
Time has a beginning, but stuff is happening before time begins.
There could be, we can't help but use this word before, right? Because it is part of our lexicon, and we're used to the familiar world of our experience. Sure. But the early universe is nothing like the world of our experience. I think that thing, all of the different models would agree on. So forget about your everyday world. The Big Bang is going to be very, very different. And there are different notions of time within physics as well. So another is what's called conformal time. So an analogy here might be, imagine you play a chess game. So when people play chess, you might see them writing down the moves. And you could put those moves in a sequence, and you could say, well, there was 6 seconds elapsed between that move, and maybe I had to think about this one, so there was a minute between this one and this one. And conformal time would keep the order, but it would lose the scale. And Roger Penrose has a cyclic model of the universe that Nia Ayesh has built upon. And this says, well, there's still conformal time, but there isn't the sort of normal time that we experience. So we don't have the scale of time, but we still have a sequence of events. So he has a cyclic universe that loses its sense of scale, because it turns out that in order to have the time that we're familiar with, you need to be able to build a clock of some time. And I don't mean a clock like, my watch, but anything that could tell the time. But if there was no mass in the universe, which may be true in the Big Bang, it might be true in the far future, then you couldn't build a clock. So you would lose our normal sense of time, but you could still have this conformal time. So a very, very different notion of time.
Interesting.
Here's a problem, Phil. As you well know, right, if we're imagining this eternal inflation, so time sort of stretches back infinitely. We've got our little pocket universe, but everything else just sort of goes back infinitely, and there's no beginning. As you well know from the study of the philosophy of religion, this is not possible, right? We cannot have an infinite past. A lot of people think that an infinite past isn't true because of the Big Bang and science, but okay, maybe we can't be so clear on that. But philosophically, we can know it, right? Like William Lane Craig talks about this all the time. Al-Ghazali proved this by just thinking about, the fact that, for example, if the universe, by which I mean the whole universe, is past eternal, then there would have to be an infinite number of events in the past, which means that there would have had to have elapsed an infinite number of events before we got to today. But you can't
have
surpass an infinite number of events because it's infinite. And so if the universe is past eternal, we would have had to transgress an infinite number of events to get to today, which you can't do. But here we are at today, which means that the universe can't be eternal, right?
No, not correct, I'm afraid. I've actually made a documentary on this Kalam cosmological argument on my YouTube channel and interviewed lots of philosophers, including religious ones. And I think it's widely rejected, this argument. So let's see what's wrong with it. The idea is, well, if you start counting 0 today, 1 tomorrow, 2 the day after that, you're never going to get to infinity. But if the universe is past eternal, then we would have had to have got to infinity. And it's certainly true that you can't get to the end of anything that's endless. That's right. But that doesn't mean you couldn't have an eternal past, because if the hypothesis is that the universe had a beginning, then there is no starting point. There's not a moment where you start at 0 and then go 1 tomorrow, 2 the day after. Rather, there is no starting point.
If the universe had no beginning.
If it had no beginning. There is no starting point. So a lot of these analogies that are used to try and prove that the universe can't have a beginning sort of assume that there's a starting point infinitely far in the past, and then you start counting from there. And the idea is you can't get to infinity by just counting. I think what they're kind of assuming is that if you start with finite and you add more finite, you're just going to end up with a bigger finite number. You're not going to have an infinite number. But the whole point of a universe that's eternal into the past is that you don't start with finite. It's always infinite. So this problem simply doesn't arise.
So you understand the grammar of the problem, right? Yeah. Which is that, okay, so there's no point at which you can start counting. But that's kind of the problem, which is that future events happen after the past ones. Past events happen before present and future events. And if there are an infinite number of past events,
this is his problem. This is what he's saying. It has nothing to do with beginning time counting and these types of things. Yeah, this is a better idea that does, I think, have more weight for the idea of there not being an eternal past than this guy is giving him credit for.
And the future events have to come after that. You understand the problem with imagining that somehow there just have elapsed in the past an infinite number of events. It sort of seems like we're at the end of this chain. Like, how should we be thinking about it? Because the only other way I can think about it is like me right now looking infinitely forward and infinitely back. Now, that makes sense. So you start with today, which is 0, and the past is more like -1, -2, -3. So there's no beginning to the past, and there's no end to the future. Sure. But then that seems to sort of metaphysically privilege the present, like me right now. Like, why is now 0? Well, it's not anymore because time's just passed. So maybe now is 0, and 0 sort of moves with me, which means that if all human beings died, there'd be no way to have that sort of privileged 0 position from which to sort of look forward and back. So without sort of arbitrarily picking the present moment as our starting point, like objectively, there's no way to even start like counting at all. There's no way for me to count today and tomorrow and because there's just no starting point. It's just like impossible to wrap our heads around.
Why would you say it's your privilege if everyone else sees the same thing that you see?
Well, for a few reasons. Firstly, because it's not clear to me that like everybody else is seeing the same thing as me, because time doesn't move linearly, right? So my 0 wouldn't be the same as your 0.
Yeah.
But also just like metaphysically, right? Like, I mean, like if we're talking about the actual nature of the universe, which means that it's easy for us now, alive human beings, to sit here and go, okay, well, let's just consider now as our starting point for our knowledge, and our knowledge stretches infinitely forward and infinitely back, and there's no problem with that, no beginning and no end. Cool. But in order to have that starting point of now, we need to exist. We need to exist in time to think of it in those terms. If there were just like no human beings, if our universe never popped into existence, or if we all just died, there'd be no conscious agent to say, all right, now is the present and we're going to think forward and back. But there still would be like an answer to the question of whether the universe had an infinite past or not. But there'd be no people to pick sort of 0 as the present, right? Because there'd be no one experiencing the present.
Right.
There would just be an answer to whether there have been an infinite series of events or not. I don't really know how to wrap my head around the idea that past events come before future events, and yet like we can sort of stretch that infinite.
And that is the thing. So you have to, you're basically at that point where you are thinking of the sort of like, past eternal, future eternal, that kind of thing. You have to essentially be saying, okay, everything's contemporaneous. Everything's happening at the exact same point in time. It's only our limited, conscious vision that says that there is a now. There is no now, there's an ever.
Right,
but I think we can all agree that this is hard to get your head around.
Yeah.
But it's true whether the universe had a beginning, that's hard to get your head around.
Yeah.
Or whether it didn't have a beginning, that's also hard to get your head around. And I think it was the philosopher Kant that said that he could prove that the universe couldn't have a beginning and that it must have a beginning, right? Because it's very, very difficult to think about. So I think we can all agree on that. But this idea of now, of course, in relativity, there is no unique now that the universe has to get to. So I think this is not something that we have to worry about. Now, could the universe be eternal into the past? There's no contradiction with that. Now, some people will say there's actually a contradiction. William Lane Craig.
Yeah, like the Hilbert's Hotel.
Hilbert's Hotel. So
anytime you introduce the concept of infinity, it leads to paradoxes.
Right.
Well, what it leads to is counterintuitive answers, but they're not actually contradictions. So let's take an example of something that's claimed to be a contradiction and try and show why it isn't. So people may be familiar with this notion of the Hilbert Hotel. This is going back to the mathematician David Hilbert. Although, ironically, it was the physicist Gamow, who was one of the defenders of the Big Bang, who used Hilbert's Hotel and popularized it, because I think Hilbert mentioned it once in a lecture, and that was it.
Interesting.
And what Gamow was trying to say was, look, the universe could be infinite and expand. Because it sounds really strange. Well, if it's infinite, how could it get any bigger? But he said, no. Hilbert's Hotel shows that it can. So in fact, the universe, and he was trying to say, look, the universe could be infinite and expand. So
Hilbert's Hotel is the idea of this hotel with an infinite number of rooms, right? There's just like an endless number of rooms, and every room is occupied. And so somebody shows up to the hotel and says, I'd like a room, please. And they go, sorry, every single room in our hotel is occupied. And they think, well, actually, I've got a solution to this. All we'll do is we'll take person in room number 1 and we'll ask them to move to room number 2. Person in 2 moves to 3, 3, 4. So everyone just moves one number up. And because there are infinitely many rooms, there's always the next room that a person can go to. So we say, okay, we've got a room for you. And they put them in room 1, which seems like a paradox because every room is full and yet there is a room for every single tenant to sort of move into. And so the William Lane Craigs of the world look at this and say, that's a paradox because the place is full. He always says, oh, it would have to say, what is it? He says, like no vacancy, guests welcome, on the front, which is a paradox. But are you telling me then that this is sort of originally formulated as a way not to say, look how counterintuitive this is, so it's impossible, but rather look at how I can prove the possibility of this really counterintuitive thing that infinite things can expand.
Yeah, that's exactly
awesome.
why it was popularized.
Hey, cool.
I mean, Hilbert didn't think about this, but as I say, I think my understanding is he gave one lecture about it. And never mentioned it again.
So often like it's so interesting how these ideas embed themselves into popular culture, sometimes for the complete opposite reason. Like you mentioned Schrodinger's cat earlier, Nayesh, which a lot of people think, they're like, I've heard of this. Doesn't quantum mechanics prove that the cat is dead and alive at the same time? Not realizing that Schrodinger invents it as basically a way to mock this interpretation of quantum mechanics. To be like, look how ridiculous this idea is. But the way it's embedded itself in popular culture is like, look how Schrodinger proved that the cat is dead and alive at the same time. It's like completely on its head. And maybe this is another example of that.
Yeah, this was an attempt to prove that we could have an infinite universe.
Right.
And
I don't think so.
Let's just go
that still expands.
Yeah, that still expands. Yeah, so let's just go to the sort of notion that it leads to a paradox or a contradiction.
Yeah, sure, okay.
So two things. One is the paradox of how can a hotel that's full accommodate new guests? And we're used to our intuitions to say, well, that's impossible because the universe that we know, all the hotels have a finite number of rooms. So, of course, they will eventually run out of space. But an infinite hotel simply cannot run out of space. There's always the next number. So it's an equivocation on the word full.
I mean, it can, because there's an infinite number of, guests. There's an infinite number of rooms and an infinite number of guests that are already in that room. So you've got, infinity spaces minus infinity guests, you have 0. So there's 0 open rooms. And there will always be 0 open rooms because there's an infinite number of guests, infinite number of rooms. Therefore, if you have one new guest, they go, no, we're full. We're full. We have 0 open rooms. That's the idea here. I'll be honest, I think my conception of that is better.
What you mean by full is
there are
someone in each room, then yes, the Hilbert Hotel can be full. But if what you mean by full is can't admit new guests, then the Hilbert Hotel cannot be full. It can never be full. So the Hilbert Hotel can always admit new guests. Now, the other thing that's claimed is that there's a contradiction, because let's suppose we take out all the even number of guests from the Hilbert Hotel. How many have we got left? Well, we've got infinitely many. So we took away infinitely many, and we've got infinitely many left. So infinity minus infinity is infinity. But now, let's say...
Infinity minus infinity is infinity. Well, okay, that's interesting.
Guests in room number 4 and above check out. Now we've taken infinitely many guests out, but we've got 3 left. So infinity minus infinity is 3. So it looks like, and Craig in a video said this is a contradiction.
Yeah, because from that you can derive that, 1 equals 2.
Yeah, exactly. But this is just wrong because infinite sets have different properties to finite sets. So in a finite set, you don't have to specify like which thing you took away. So there's a table in front of us now. There are 3 cups in some sense, 2 glasses of water and a cup of coffee. Was it, Alex?
It was, yeah.
Right. Okay. So if I said, there's 3 of these things on the table and I take 1 away, You don't need to know which one, whether it was one of the glasses of water or the cup of coffee away. You know, I take one away, there's two left, right? But for infinite sets, you have to specify which things you took away. So once we specify which things we took away, well, we didn't do the same operation. When we took the even number of guests away, that's one operation. When we took all the guests in room 4 away, that's a different operation. They are not.
You can't just say
same.
infinity. You have to specify the. It's like the difference between saying, okay, so there's a coffee and 2 glasses of water on the table. If you say, okay, well, if I take one away, I'm going to take this glass away. How many glasses of water are we left with? 1. Okay, right. Let's go again. Now I'm going to I'm just going to take one away. This time I took the coffee away. So how many glasses are left on the table? Well, there are 2 glasses of water on the table now. So in both cases, I've taken one away, but one's given us 1 glass of water and another has given us 2 glasses of water. But yeah, because it depends what you take away. You can't just take away one. You have to take away one of something. You can't just take away infinity. You have to take away a particular, set of infinite things, a particular kind of infinity, right?
Yeah, so infinite sets have different properties to finite sets. And I think the power of this argument is that it carries off your intuitions about finite sets. And you think that the finite sets must have the same properties as infinite sets, but they don't.
Okay. Nyayesh, what's your thoughts on this? What do you think about the plausibility of an infinite past? Do you place stock in it? Do your intuitions scream at you that there must be a beginning?
Yeah, I mean, infinity is all over mathematics, right? So it's, I mean, all this stuff, I mean, I kind of, we talk about it at high school or middle school or whatever, but you don't do stuff with regular infinity that you do with regular numbers. It's just, no. Yeah, I mean, it's perfectly fine part of math if you know exactly where it comes and what to do with it. When it comes to physics, I mean, again, we build physics using mathematical language. So same places that there's infinity in math, there's infinity in physics because it's just the same thing, right? But then the question is, so where are the places in physics where infinity cannot be? And if I'm measuring something, like I'm measuring the time or temperature in this room or anything I measure, it doesn't make sense to say that I measure infinity. So those are the places where infinity is not allowed, because that's not a real number. That's not a measurable number, right?
Right.
Anywhere else, it's fair game, because I mean, as long as it appears somewhere that's it's not directly prediction of a measurement, and I can still do my predictions, like I can make calculations, right? There's really no problem with infinity. So as long as I have a way of dealing with it, right? So that's the thing. Now, that being said, having an infinite time is kind of rubs me the wrong way, because it's kind of the same as a multiverse, right? As you're saying that, okay, there's an infinite universe, infinite many pockets with various properties I don't have access to. It sounds like science fiction, but also it kind of feels that it goes beyond the realm of physics, because I cannot really constrain them, and there's no testable prediction. And of course, this is a controversial topic, an exciting area of debate, that, okay, is multiverse testable or not? And we do talk about some of the potential ways of testing it. But I mean, for the most part, it's either untestable or very hard to test. Infinite time is kind of the same. Right. And this in my view, because if there are things that happen a very long time ago, like long before the hot Big Bang that we see, I mean, were they there, were they not there, doesn't matter. So we could talk about it from a mathematical standpoint, but is it part of our physical language, or should it be part of our physical language? And that's the part I'm kind of more skeptical, which is, it kind of goes hand in hand with this skepticism, eternal inflation, and multiverse. So my own favorite, so I think we talked about Hartle-Hawking model, where there's time begins to exist at some point, didn't exist before some time. We work on a different model called holographic cosmology with Kostas Skenderis and others.
Holographic cosmology.
That's right, holographic cosmology. So holography is this very, very exciting part of theoretical physics, which actually came out of a string theory in the past 30, 40 years. And the idea is that maybe if you want to describe gravity in a quantum sense, you shouldn't think about gravity in a space and time. You should kind of think about boundary of the region, and think about quantum mechanics in the boundaries. So there is this idea of holography that really understanding gravity is like understanding quantum mechanics in one lower dimensions, which is like holograms. It seems like you see something three-dimensional, but it's really two-dimensional. So so one way to describe it is that maybe one of our dimensions, it could be one dimension of a space or one dimension of time, is kind of an illusion.
Okay.
Yeah.
Pause. So
Yes.
a holograph.
Yes.
People are familiar with these things. Like you get them at like, little stores on the side of the beach or whatever. It's a 2D plane, but it kind of looks 3D, right?
That's
you look at it from different angles and it shifts and it moves. It is actually 2D.
It's actually
but
2D.
It has the appearance of 3 dimensions as you sort of move around it.
Yeah.
The idea of holographic cosmology is the idea that one of our dimensions of time or one of our dimensions of space or maybe the dimension of time works in a similar way, that there's actually only 2 dimensions and the third dimension is a holograph, or there's only 3 dimensions and the dimension of time is a holograph. And
that's right.
I think he's talking specifically about gravity. Like, okay, like we've got like this thing of one of those dimensions, and then it sort of like rises up. Gravity is a sort of it appears to work on these other dimensions, but is actually only one lower one. I'm probably wrong.
Therefore, like an illusion.
This is a good question. So, now illusion is a kind of depends on your definition of reality, right?
Yeah.
Now,
like it's there, but it's
three-dimensional kind of description. In this room, we're talking, we're moving around, up, down, left, right. We can wait, so move forward in time. So that description of 3 space and 1 time works very well. Okay, so you may think it's an illusion, but it's a very good illusion. Like it's a very, very convincing illusion, right? There might be a different description of this room without 1 extra dimension. You could imagine it exists. It's just very contrived and a strange description of these events that are happening if you don't use, let's say, 1 of the dimensions, right? It's possible, right? But it's just not very convincing illusion, right? And the idea, this idea of holography is that really there are 2 ways to describe things. One of them might be easier, at least in some language, in the language that we're familiar with, but that depends on the situation, right? And we know there are situations where this 3-dimensional description becomes very contrived, and those are near singularities, right? So these places where quantum gravity plays a role, where basically there are strong fluctuations in geometry. You could have black holes popping in and out of vacuum. You have very strong curvature. So these are places where we really understand we need to understand quantum mechanics and gravity playing together. And right now we don't. So in such situations, in fact, a more satisfactory, more kind of simple.
This is interesting because most of these theories, I mean, I'm not intimately familiar with all of them, but most places are not like taking away, like, okay, we've got 4 dimensions, we've got, length, width, depth, and time. That's it. We got 4. It's like, no. Most of them are like, we've got more than that. We'd have like 5 dimensions, and like your 5th dimension would be gravity, And it's not, it's like, it's like our 5th dimension is gravity, and basically, it interacts with ours through that, holographic thing. That's what I've heard. From what he's explaining, I guess I got it wrong, or maybe this is a specific theory or something like that.
The described language is a language without 1 of those dimensions. Now, this dimension you're taking away, it could be a dimension of time or it could be a dimension of space. And depending on the setup, the problem you're trying to solve, the kind of singularity that you're dealing with, it could be a dimension of a space that is easier to take out of a dimension of time. And for the Big Bang, this holographic cosmology, the idea is that when you get close to the Big Bang, or Big Bang singularity, if you want, so past the hot Big Bang, maybe, close to Big Bang singularity, this is where this 3 + 1 dimensional description breaks down, and maybe you just have 3 dimensions of a space. No dimension of time. No dimension of time.
Just dimensions of space.
Just dimensions of space. So that's
okay. And then quantum gravity is just or gravity in that sense is just a force. It's not part of the dimensional stuff. It's that time is an artifact of quantum gravity. Okay. Okay.
That's an example of the basically you have regular time all the way down to some point, and then at that point, it's not that the time stops to exist. It's just that your description, your stories in terms of time becomes more and more convoluted.
Is this
right?
a version of time being like an emergent property?
That's the idea.
Okay.
So in
Right,
this case,
because-
time would
so,
get
so
emergent.
as you go towards the Big Bang, it gets to a point where it's not that time ceases to exist, but you're operating on a level where this holographic illusion, if you like, of time, it just sort of doesn't apply in the same way that temperature is an emergent property in that like things are hot and things are cold, but if you go small enough down as the atoms, you realize that temperature is just atoms vibrating, and an atom vibrating is not hot or cold in itself. You have to zoom out before you get this concept of temperature, which is emergent. You know, a cake is spongy. But if you zoom in and look at all of the atoms it's made of, none of the atoms are spongy. You have to zoom out. And it's not like when you start zooming in with a microscope to this cake, sponginess just disappears. It just, you're operating on a level where it just hasn't emerged yet. And time might be a property a bit like this, where not so much zooming in, but going backwards towards this Big Bang singularity.
Yeah.
Time as an emergent property just sort of doesn't apply here, or something like that.
That is an excellent analogy. In fact, we have a technical word for exactly the zooming in and out. It's called holographic renormalization.
Holographic renormalization. I prefer the cake thing.
Yeah.
Well, I mean, Phil has a video about holographic renormalization. I think
Phil's got a video about everything.
Yeah. It does seem like
That's
it.
right. Yeah.
So is this how, like, I mean, one phrase that we often hear, especially in like popular apologetics and just general sort of discussion, is that the laws of physics break down at the Big Bang. And this often is used to indicate this impenetrable epistemic boundary that we sort of can't really discuss or talk about the Big Bang scientifically, because that's where our laws of physics break down. Is that true? Is there a sense in which that's true? And if it is true, does it place the Big Bang like outside of scientific apparatus, if science relies on laws to sort of explain the universe, and these laws break down at the Big Bang? You know what I mean? I mean, it sounds a little bit like when time stops existing, it sounds like, you know, physics beginning to break down. But I don't know.
It does seem like it.
Before,
yeah, of course.
Do you think it makes sense?
I think that the case is that it's general relativity that breaks down at the Big Bang.
Interesting. Okay.
So it's not necessarily the laws of physics break down, but rather the laws that we have break down. And what people like Nia Ayesh and other cosmologists are trying to do is to expand what those laws are, to sort of give us new laws in the same way that we had Newtonian physics and then Einstein gave us new laws. But it wasn't that new laws came into existence. As you pointed out, Alan Guth didn't invent, the inflation. He invented the theory. So this is what physicists and cosmologists are trying to do. They're trying to discover the laws that actually hold at the Big Bang. So Stephen Hawking famously said, that in his no boundary proposal, the laws of physics would hold everywhere. There's nowhere where the laws of physics break down. So this is what we're trying to do. We're trying to push our envelope of knowledge to go beyond that point where they break down. And this is where the controversy is. And this is what the battle of the Big Bang is all about, because we don't know what those laws are. There's lots of proposals. There's string theory, there's loop quantum gravity, holography, all kinds of ideas. And so we don't know which is the right law to use, but that doesn't mean the laws themselves break down. They may always exist.
That's interesting. I mean, I kind of wanted to get to this in a moment, because I wanted to talk about universes coming into existence out of nothing. But like, Vilenkin has this idea of universes that can pop into existence out of nothing. And in your book, you talk about how there's this criticism that you've made to him in your video, that this would require these laws of physics to like exist before the universe came into existence. Because if you imagine like the universe cropping into existence from some quantum fluctuation, that means the laws governing quantum physics must predate the universe. And Vilenkin says that he just thinks that the laws of physics just exist like as a platonic object. They're just these things that just definitely exist.
Which is stupid.
That's definitely not my view of the laws of physics, but it does lead to this interesting question of like, it does seem like there needs to be something exterior to all of this, right? I would say that even if the universe were past eternal, there's still a good argument to say that it requires some kind of sustaining cause. And this is something which someone like Aquinas agrees with. Like, I think Aquinas thought that the universe did have a beginning, But he also said that even if it didn't have a beginning, it would still need some kind of cause. So maybe I can begin by asking, and maybe this is a question.
Which definitely makes the most sense to me.
If the universe did have a beginning, if we did know that it did have a beginning,
for sure,
right? Either the beginning of universal inflation, or there is a Big Bang singularity or something. If it did begin to exist out of nothing, do you think it needs a cause?
Personally, my opinion is no. We certainly can't demand that it must have a cause.
Okay.
Let's just unpack what we mean by a universe from nothing here, because there's different notions of that.
Yep.
So one you mentioned was it was coming from a quantum fluctuation of the vacuum.
Yeah.
And that's an older idea of a universe from nothing that goes back to Edward Tryon. And when people sort of make criticisms of the idea of a universe from nothing, they say,
that's not nothing.
That's not nothing, because that's a vacuum. And Neil Ash talked about the vacuum is not nothing.
Vacuums can't be.
It's got all kinds of activity in it. But what Vilenkin suggests is something quite different. Here, the idea is, well, what if we treat space, time, or space itself quantum mechanically? Then his idea is that space itself would fluctuate into existence. So it's not coming from a vacuum.
So where's it coming from?
In his view, it's coming from a state with no space.
Okay, so just to be clear, when I say nothing, I'm talking about, like, as Aristotle said, what rocks dream of. I'm talking about what you see out of your elbow. I'm talking about nothing, right? And it like, even to say from nothing, the way that I've pictured that in my head is I imagine sort of darkness and then something pops into existence. But no, there's no space, there's no extension, there's no anything.
But that's right. In Vilenkin's model, there is no space. The way you can think of it, you've been involved in philosophy of religion, Alex, and you'll be familiar with.
Also, you'd say, hey, look, there's no laws, there's no, nothing is essentially the thing from which nothing can come. Only nothing can come from nothing, because it's nothing. There's no laws, there's no possibility of anything other than nothingness.
Idea that God created the universe ex nihilo, no materials. So that's what we're talking about here. It's exactly analogous.
It's not
the
nothing.
Universe is created ex nihilo, nothing material that we know of. Nothing like anything you can see in this room, not even a vacuum. So no space.
So Phil, why aren't you worried? If you think things can begin to exist without causes, then why aren't you worried, as the common line of argumentation goes, that a deer has just spontaneously begun to exist in your kitchen and is currently destroying it? Shouldn't you go and check?
Well, I asked Vilenkin this. I sat in his office and I asked him, I said, why can't a tiger just appear in this room? And actually, he said to me, well, tiger could appear in this room. There's a quantum probability of that happening.
Yeah, that is true.
Right? But it's just unimaginably unlikely, so no need to worry about it.
But that wouldn't be out of nothing, right? That would be out of the...
No, that wouldn't be out of nothing.
Yeah. So why aren't you worried that a tiger might pop into existence out of nothing? Not as a really unlikely quantum fluctuation of atoms or whatever, but out of just, like, nothing. There's no space, there's no nothing. It just a tiger just appears. Why aren't you worried that that's going to happen right now?
Right.
Well, we're not in nothing. So
that's that's kind of getting into the von Neumann brain type thing.
Come out of nothing. Well, that's not where we are. We're in this universe, so it has to play by the rules of this universe. Now the question is, could a tiger appear out of nothing, like not empty space, sorry, just no space?
Nothing,
right? Well, what Vilenkin tried to do was to use inflation. Say, look, the probability of a universe coming out of nothing and actually lasting is incredibly small. But what he suggested, and this is why it's called tunneling from nothing, that it could tunnel to a state where it would then inflate and become a big universe. So if it was just a tiger with no inflating energy, then it would just sort of go back into nothingness, as it were.
Sure.
But so now let's go on to this issue of causality.
Yeah.
Right. Yeah. So if the universe came from nothing, would it need a cause? Now, what I want to do is ask the question, well, let's suppose God created the universe. Does God need a cause? Right? And the reply is often, well, God doesn't need a cause because God doesn't have a beginning. It's only things
necessarily exists.
God doesn't have a beginning. It's only things that have a beginnings need causes.
Yeah, that's how the Kalam.
Okay, yeah. So that's in the Kalam argument. Now, that's not the statement that God exists eternally into the past, right? But rather the claim is that God exists timelessly and then enters into time. But now let's go back to Nietzsche's holographic cosmology model. That also exists timelessly and then enters into time. And we might make an argument for the
That's cool. I like
Horsegirl
that.
model, which also has a timeless state. So here, maybe then we could say exactly the same thing, where it doesn't need a cause, right? So the question is like we said about water being emergent, causality may be emergent. So then when we get to the quantum realm, maybe causality doesn't exist. So causality is a feature of our macroscopic universe. So we can't assert.
So this is an interesting thing, because you'd say, all right, well, if causality is an emergent phenomenon, then wouldn't logic also be an emergent phenomenon? Like, logic is very much like, if A, then B, not A, not B, blah, blah, blah. That's causality. That's where pretty much all of our logic and, axioms and these things come from. So if that's an emergent property, then logic is not necessarily, there's a point at which logic doesn't exist anymore.
That these things must have a causes, because we don't know if causality is fundamental.
Yeah, this is kind of like a version of when people say, well, the universe needs a cause, and that cause must be God. There's some kind of first cause or some kind of necessary existence. And a very common response to this from atheists is to say, well, in some sense, the universe can serve that role. Right? The universe is this brute fact. The universe necessarily exists. People come along and say, no, the universe doesn't necessarily exist. It had a beginning. How do we know that? Hilbert's Hotel, the Big Bang. We've gotten rid of those ideas, right? So let's say that we can no longer dismiss the idea that the universe is this fundamental thing, which sort of, from which everything else stems. And all of the qualities that exempt God, I think legitimately, by the way, philosophically, I don't think it's a cop-out to say, well, God doesn't need a cause. I think that's perfectly philosophically legitimate. What we're saying now is it might be equally legitimate to apply that to the universe or whatever sort of was the Big Bang or before the Big Bang. Here's the question, and this might be a question for you, Naish, because you've got this holographic view of time. And earlier, this is what I was trying to wrap my head around. Time doesn't exist, and then it does exist. Here's what the theists say, and here's what I say when I'm on my sort of theist day on. I say, okay, so we've got this timeless cause, but we've got a temporal effect. Right? The universe, which has popped into existence, it has time. It's got a temporal effect. But the cause is existing timelessly. In a sense, it sort of exists, you might want to say infinitely, maybe not eternally, but definitely timelessly. Here's the problem, right? If you've got a timeless cause that just exists timelessly forever, there's no beginning to it, it just exists.
You used to said forever, so that doesn't mean timeless.
Exists outside of time. There's no point in time at which it doesn't exist. Let's say that, right? If there's no point in time at which this cause doesn't exist, if that cause is causally sufficient to bring about an effect, I imagine it's like it entails the effect. Imagine the cause entails the effect. If you've got a cause which has the ability to bring out an effect, and that cause exists, there's no point in time at which that cause doesn't exist, then since that cause brings about the effect, there should be no point at which that effect doesn't exist, because the cause brings about the effect, the cause is timeless, so the effect should be timeless too. In order to have a timeless cause
maybe
that yet brings about an effect at a point in time, that cause needs to do something. It needs to have, in other words, as the theist would say, a will, or it needs to have some kind. It can't just be this inert law, because laws apply all the time, right? Laws, laws don't sort of change, fluctuate. So you've got this.
That's not necessarily true.
No point in time at which the cause doesn't exist. There should be no point in time at which the effect doesn't exist. But if there is a point where the effect doesn't exist, but no point at which the cause doesn't exist, the cause must do something, must have some kind of will. We're looking at something that looks a bit more like God than some foundational law of the universe, right? You get what I'm saying?
It seems to me that it's kind of getting more complicated than it should be. I mean, I guess that this timeless story, maybe it's, we misstated it. I guess it's timeless in the sense that in this earlier state, there is no time, there is only a space. But you could also say it exists at one time. So I don't. It's not that it exists all the time. So this
okay.
initial state, this three-dimensional timeless state. It's not that it exists eternally. It just was there.
Right.
That's
Okay, so then in that case, you're saying that, I mean, like that point in time is it very much a beginning.
proper way of understanding universe at early times. Now, here's the thing. It's not that there is one or the other, right? So I think you're kind of separating the cause from the effect. And I think maybe, okay, so maybe in a kind of roundabout way, I kind of agree with you, because this idea of holography is not that one is real or the other is not real. So the idea is that there are two different descriptions.
Mm-hmm.
Okay. There is one description with time, and there's another description without time, and they're equivalent description. There's not one, neither of them is higher or better or different from the other. They are the same descriptions. They're just easier to kind of put it in human language or mathematical language in some situations. One is easier in one situation, the other is easier in other situations. But nonetheless, they're equivalent. Okay. So in that sense, I think I agree with you that if you want to say one of these is the cause,
Yeah,
the
weird.
timeless one is the cause, and time full one is the effect, then they are in fact the same things. So we are the God. Is that right? Is that
Well, you know, I really thought we'd get to the end of this without any kind of blasphemy. But we just about managed to
Barely.
it in. Okay,
okay.
that's interesting. And of course, like a model like this holographic universe is even if we spent the whole podcast talking about it, there's too much to go into, which is why once again I will wave the book around and
There you go.
people to go and buy it, because I mean Carlo Rovelli on the front cover describes this as an intellectual feast, and I think he is right. It is phenomenal. So many questions left unanswered. I mean, one is to say that, like, okay, so we were just talking about this, Phil. Recently, Joe Rogan went viral for saying that he's, quote, sticking with Jesus. Reason being that the difference between science and religion is that science only asks you to believe in one miracle, that the universe just sort of pops into existence out of nothing. Okay, maybe that relies on this idea that the universe has a beginning at a point in time, which, as we've discussed, it might not. The universe might be infinite. But as I said, even if the universe is past eternal, it still seems that there would be some reason why that eternal thing exists.
I think his philosophical objection to the idea of like a past eternal, there's an infinite number of events before now, is a good, legitimate objection to the idea of there being an eternal past, aka one with no beginning, which does make it seem like, yeah, there is probably a, 0 point start of the universe. I think it's a good objection.
Joe Rogan says that the miracle that the scientists ask you to believe in is that the universe just sort of exists for no reason or out of nothing or however you want to think about it. And like, if you think it's so ridiculous to believe in the miracle of the resurrection, isn't it equally ridiculous to believe in that kind of miracle? And isn't science therefore ultimately based on a similar kind of faith?
Well, let's separate the two miracles, right? One is that the universe came from nothing. And I think we can say for sure that we don't know that to be true. It's not impossible. Vilenkin has this interesting idea, but as we explored, there are lots of interesting ideas, and we have to embrace the uncertainty. I think that's kind of the theme of the book, is when people tell you, the universe came from nothing, or it had a beginning, or all kinds of ideas, embrace the uncertainty, because we don't know, right? So we can't say the universe came from...
I think most of the theories they've been kind of expounding on in here are either kind of like from nothing theories, or ones that go, okay, well, like the observable universe didn't come from nothing. Okay, but that doesn't mean, like, you're not going back far enough then. Like, you're not answering the question. You're just saying like, okay, yeah, the Big Bang's not the start. And I was like, okay, that's fine. But that doesn't mean that if the Big Bang's not the start, there is not a start somewhere. You just haven't, gotten to it yet.
Nothing. So Joe Rogan, I think, is just misstating the case here. But that doesn't mean we shouldn't address this issue of what's the reason that the universe exists. So another interesting model that we haven't talked about too much is this idea of a time loop. And interestingly, this would also challenge our notions of cause and effect, right? Because what's the cause and what's an effect if we're on a loop in time? And William Lane Craig said that this was a
if there's a time loop, if there's like, it's, okay, we've got an infinitely expanding universe, and then it contracts, we get a big crunch, and then we get boom, we get another time loop, and it's the exact same universe again and again and again. Dude, come on, that is like straight up nothing but you've got to have a creator for that. Like there's just no logical way I can see around it other than just being like, well, no, nuh-uh, doesn't have to be. I'm like, yeah, okay, you're not helping.
Desperate attempt by atheists to avoid God. But what he didn't know is that Richard Gott, who came up with this model, was actually a believer. So the question might still be, well, why does the universe exist? And, I think what we can do in cosmology is not necessarily to answer these really big questions. I mean, that's for philosophers.
There you go.
And what cosmologists want to do is push the envelope of our knowledge. So we've got to point the Big Bang where our knowledge currently sort of stops. And what cosmologists want to do is push beyond it. And that's the battle. But I don't think that's going to give us answers to, why does the universe exist? I mean, you can try and make inferences about it. Like if we look at the Vilenkin tunneling from nothing model, you could say the universe exists because the laws of physics exist. And maybe the laws of physics are necessary. Maybe they just couldn't be anything other than what they are. So if you're looking for the necessary thing, maybe it's not God, maybe it's the laws of physics. And I kind of like that better than God because we know the laws of physics exist in some sense. Now, exactly in what sense they exist, that's the thing for debate. But I like that better than God because I think, well, laws of physics seem more parsimonious. But of course, this is a speculative idea. And maybe there is no reason. Maybe it just is. And, I think Bertrand Russell just said the universe just is, and that's it. So I don't think cosmology is going to settle those questions, but what it can do, what we hope it will do, is push the edge of our knowledge from just after the Big Bang to maybe.
So Joe Rogan might have the wrong idea of what the Big Bang is and what you're required to believe to accept the Big Bang. But it's not illegitimate of him to go, but look, at least the kind of scientist that says, well, the Big Bang has, done away with our need for religion and sort of has explained everything. Actually, no, in order to think that the Big Bang has somehow explained the beginning of the universe, you kind of are believing in some kind of miracle, if at least the miracle of explanation, which scientists just cannot even begin to approximate right now. Is that putting it too strongly?
I don't know if I'd want to use the word miracle. There are certainly unanswered questions that I think physics, it's not setting its task to answer.
Do you think Joe Rogan is embodying like an illegitimate like criticism there as a whole, which is to say, okay, maybe he's got the wrong model of the Big Bang or whatever, but even if we corrected that and said, Rogan, like maybe the universe didn't come from nothing, maybe it's past eternal, he goes like, oh, okay, that's interesting, but like, man, like still there's this question of like why it exists, and the scientist is just asking me to just accept that there is some reason that we just don't know, and it's like, man, I'm sticking with Jesus because that's more sensible to me.
Right.
Well, we ask you to embrace the uncertainty, and sticking with Jesus is not embracing the uncertainty.
So you're not asking someone like Joe Rogan to say, don't stick with Jesus, stick with, the quantum loop theory, because that's the great. It's rather, don't stick with Jesus because we don't know what to stick to yet. Maybe it's Jesus.
Yeah.
And maybe if it is Jesus,
that's a little bit more reasonable.
The method we'll
I'm okay with
use
that.
to find that out. But the resistance to this religious impulse is not because you have a better explanation, but just because you have alternative explanations and we don't know which one is the correct one.
I think that's
fair enough.
Perfectly. Yeah.
Nayesh, do you have a view on this?
Yeah, I mean, I think this is just a misunderstanding of kind of scientific methods, saying that a miracle, of course, is a loaded word. Depends on if you're religious or not. Depends. You feel differently about it, but. And the thing is, you asked this earlier, that okay, does the rules break? Do the rules break at the Big Bang, or do? And I was gonna say, and I can kind of say that again. Like 150 years ago, the rules of physics broke at the surface of the sun. So
Yeah.
This is a good point.
Was God there?
Yeah, and at some point, the laws of physics broke near the speed of light.
Yeah.
The laws of physics broke, with really, really heavy objects.
That's right, absolutely. I mean, at various stages in the development of science, we had certain rules or laws, approximate ones, and they were very good in some domains, and then we pushed them, at some point they broke down. And 150 years ago, that was the surface of the sun.
Right.
And then we learned about relativity, learned about nuclear physics, and then we could then explain how plasmas behave, how convection works in plasmas, and how nuclear fusion works. Now that point is near this Big Bang singularity or a hot Big Bang. Are we making progress? I think we are making progress. I think we're pushing further. But I mean, it's kind of an arbitrary point to say that, okay, so now this is where the science is going to end here, definitely. And yeah, it could have ended, I suppose, any point in the past 300 years at any point, but it hasn't. It's been making progress steadily, and we're doing the same things. But I think about kind of broader implications of whether, is there room for religion in science? I think there is. I think this is more of an evolutionary question as opposed to maybe scientific. Still a scientific question, but maybe science of humans, not science of cosmology. Which is to say that, cosmologists are humans, and humans have lived with religions for thousands of years, if not longer, as far as we know in history.
I got you. It's not necessarily. Religion is not the same as God. So is there a room for God in science? He's not answering that. Is there a room for religion, as in, can scientists be religious minded and still do good science?
Question, and this is the question I like to ask, that you can take a cosmologist out of religion, but can you take religion out of a cosmologist? If this is something that's built into our DNA, you could say, I'm not Christian, I'm not Muslim, I'm an atheist, but then you're still living life the same way that your ancestors have been living. And on the surface is very different, but we are still drinking water, we're still breathing air. So certain things in our brain may work the same way. And maybe we kind of develop religions in new senses, like, for example, is inflationary cosmology or a string theory modern day religions? And we kind of go into length as to what extent that question even meaningful, right? That maybe in some sense there are similarities, but then also there are differences. Where we do make connections to experiments or nature, we pose testability or falsifiability as a criterion. Maybe that's where we try to distinguish ourselves. But this is a very fuzzy kind of gray area, exactly where science becomes religion or vice versa. So it's but I think that's one thing that I think religion. As much as we may want to distance ourselves from ancient religions, I think this is part of our society, and it may show up in different guises in terms of dogma.
Yeah, I think this is just how people, human beings are attracted to dogma, no matter what it is, and therefore there's a lot of defensiveness if you're an atheist and you're confronted with an idea that's like, well, doesn't this kind of disprove your idea that there's no God? You're going to be inherently defensive just because you're human, not because you're, an atheist or rational or any of these types of things. It's like, no, in these things, we're all inherently irrational, or at least we want to be.
Or in terms of the way we build communities, religion has been used to build communities for thousands of years, and we build communities among scientists. Are we using similar practices?
Yeah,
right?
Science is not immune from dogma. This is the point. And in fact, we were just talking before we shot about how, is it chapter 10 of the book that talks about the relationship to religion and science? And you want to ask the question, as if I just asked to you, Phil, sort of, well, is there place for religion within, or is there space for cosmology within religion? Does cosmology sort of fit within this religious picture? The question you want to ask there, Nayesh, is there space for religion in cosmology?
Right.
At least those elements of religion which involve dogma and faith and belief without evidence. that can occur in science too. And the history of science is littered with people who are unable to accept consequences of particular ideas because of essentially dogmatic assumptions. Famously, Einstein's blunder. I talk about that a lot on my show. Ironically, maybe he was right, in a way he didn't realize, but the idea that, his theory of general relativity showed that the universe had to be like, he believed that the universe was eternal and static. But general relativity said that it would all collapse.
Right.
And so he introduces this cosmological constant which holds it in place. And then when he realizes that the universe is actually like expanding and not, static, he's like, I was so silly. He takes it out. He calls it his greatest blunder. And it was because of a philosophical commitment that he wasn't sort of willing to let go of. And philosophical commitments have gotten in the way of science, not just like religious institutions standing in front of scientists and saying, you shall not enter, but scientists themselves unable to shake certain conceptions. And one of my favorite things that I've just thought about that you do in the book, when you're talking about the multiverse in particular, and this idea that the multiverse is ridiculous and like, it's so silly and speculative, and as if there are billions of multiverses, like, come on, universes. And you very briefly, in like one sentence, track this history of science where you say, well, it used to be that the Earth was special and there were no other planets. Then we discovered actually there are other planets. But our sun is really special. We realize that the planets go around the sun, and our sun is this really special object, separate from all the stars. And then we looked at the stars more closely, and we realized actually there are billions of suns, and all those little stars are actually the same as our sun, and there's nothing special about it. And then we thought, okay, but like all of these stars are sort of collected into this galaxy, and there's this one galaxy that we all exist in. And then we started seeing these fuzzy objects in the sky, which Kant calls it an island universe. And people are like, no, it's just some kind of weird star or something. And then thanks to the work of the Harvard computers, some very, very like undersung heroes, women who were sort of doing the calculations that allowed us to discover, because of a particular kind of star in those fuzzy patches, that actually those fuzzy patches are galaxies as a whole. So first the Earth was special, then it wasn't. Then the sun was special, then it wasn't. Then our galaxy was special, then it wasn't. There were lots of galaxies. And now our universe is special. Where's this heading? I don't want to extrapolate unfairly, but it seems at least plausible that one day we will look back in the same way as we look back on those instances of science. And people who are unwilling to accept that as a conclusion may just be beholden to philosophical ideas. Not to say that you have to accept it's true, but if you are just unwilling to entertain its plausibility because it's just ridiculous, think how many times that has been said about so many scientific ideas.
The funny thing is like multiverses are such a normal part of just like cultural fiction nowadays that I feel like physicists are the only ones that are holding out. Everybody else is just like multiverses, and I was like, yeah, it's like what they're doing in the DC, Marvel, that kind of stuff. Yeah. That sounds reasonable, right? They've got like the branches and stuff. Like you could go left, you could go right, you go both ways, and universe A and universe B are created.
To the extent that scientists have been like laughed out of the room. The first guy to like look at the continents and think, it kind of looks like the Americas slot into like Africa and Europe, laughed out of the room,
Right.
Yeah.
And yet we now know that to be the case. I think it's a good reminder. And I think reading a book like this, as I say, it's in part a history. Going over the history of this happening over and over again is a reminder to be like, we just don't know, man.
Right.
We just have absolutely no idea. Maybe we will one day. But for now, at least, I think this is the best we've got. And I think this is one of the best overviews available in print. It probably is the best available. I should have said the best available. Honestly, guys, I told you this earlier. I think the book is a triumph. I think it's phenomenal. It's gripping. It's so well written. It doesn't have any bloody maths in it, which is
That's
awesome.
good.
And it covers all of this kind of stuff. We didn't even talk about whether you can create a universe in a lab. We didn't talk about quantum loop gravity.
All right, that's it. He's wrapping it up, so I'll wrap up. And we're going to move on to this one, which this guy, the Gary Stevenson, Gary's economics guy, this guy, I don't like him. I just find him personally like aesthetically repugnant. I just don't like just the mannerisms and stuff. I don't like him. Andrew Wilson, I like a little bit more. I don't know. I feel like I want to try to. Here we go. I'm gonna try to record this so I can try to make a video out of it. Which means I'm gonna give it an introduction, like a jackass. All right. So we're taking a look at Gary Stevenson, Gary's Economics, and how Andrew Wilson eviscerates him. I hope we will all enjoy.
There's this guy. I think this guy is more of a left wing, talks a lot about leftist economics, very popular over in the UK to have these guys who are these sort of like, they kind of talk like roadmen, like your average guy. You can relate to them.
But he's like a millionaire and was like a banker for years. Like he made all his money like that. But he's very much he's a man of the people, though.
And they are very into their leftist economics. This guy here has gotten a lot of traction recently, and he's talking in this clip about the divide between left and right and the way in which the culture is moving. So I want to get your take on this.
Everybody in the street knows the political center has failed. Everybody knows. So something has to change. There's a quote from Milton Friedman, American economist. At times of crisis,
we start immediately with everybody knows.
Yeah.
Well, you know what, sir? Everybody knows that what you're saying is not true. Okay, so we start with that supposition, right, Jake?
Yeah.
And then I can build a logically consistent case based on that, can't I?
Yeah,
we just have to start with something completely flawed to begin with. So he starts with a bullshit position.
I mean, it's not totally bullshit. It's like, okay, hey, do the majority of people think that he says the political center? I don't know if he means the political center in terms of like, the moderates, conservatives, centrists, I should say. They're wrong, or if he means like the political center of politics, elites are wrong. I think probably you could make an argument that the majority of people, not everybody, obviously, I think he's talking, hyperbolically, and he's saying the majority of people, a lot of people, believe this thing. Now, it doesn't matter if they believe it. They could be, like everybody could believe something and it'd be totally incorrect. Everybody could believe that, the sun revolves around the earth. That doesn't mean it's true. Okay. And the idea that you're then going to try to use that justification of everybody believes this thing to be true, and you're going to build out from there. Yeah, that's bullshit.
Everybody knows, and then builds an entire case on the everybody knows in order to give himself some sort of validity, right? And these people are, the guys like this, they just get torn apart. I tear them to pieces. They're so stupid. But anyway, go ahead.
No idea will be chosen from the ideas lying around at the time. Everybody knows that we will get something new in politics. And it is really obvious what the loudest idea lying around now is, which is the far right. And the second loudest idea is us, tax the rich. So if you are a billionaire and you know that politics is going to move either towards the far right or tax the rich, what are you going to do? You are going to fund the far right. And they are doing it aggressively. Look at what Elon Musk is doing. These guys know that they don't want to pay higher taxes, and they are...
It's almost like
I'll pause too. I love that they're saying this. It's like you couldn't look at the past and you couldn't say anybody other than Elon Musk. You can't look at, these billionaires and be like, all right, who is actually the majority of, funding? Where are they going? Are they going to the far left or far right? Most of them have been funding the left. Like, I mean, you're looking at the Mark Zuckerbergs, you're looking at these things. Yeah, like a lot of these people are ideologically leftist, way more so than right-leaning, because I mean, the majority of these big giant billionaires are tech people, and tech, generally speaking, it attracts left-leaning progressive people.
Dialectic between right-wing traditionalists and the left-wing tax the rich people has just emerged, Andrew, 2 minutes ago.
Well, not only that, but the reason that the ultra wealthy fund both sides of American politics through NGOs and lobbyists and everything else is because they're hedging their bets. They're not going to pay regardless.
Obviously. I mean, this is the real thing that you want to be looking at. Why are they doing this? Don't you think they could spend that money better on their own, selves? Like, hey, I'm going to spend $200 million on like a, 2020 presidential campaign to advantage one side or the other. Okay, you don't want that $200 million? You could buy a lot of stuff with $200 million, all right? Like, I know you're rich and you've got money to spend, but you could certainly keep that money. So why are you doing that? Well, it's because, having the government in your back pocket is important if the government is so enormously huge that it can just blow up your fortune. It can just seize your assets. It can do whatever the hell it wants to, and you have no recourse whatsoever. So, I mean, as a libertarian, I always just say, yeah, you can kind of solve this problem by making government smaller.
Of who's in charge.
If you want to get money out of politics, make politics less attractive to moneyed interests.
Okay? It doesn't matter who's in charge. The ultra wealthy are not going to be paying taxes. Do you know why, Jake?
Why?
Because they write the tax policies.
Yeah.
See, what happens is the ultra wealthy, like George Soros and his think tanks, they write legislation. They write tax policy. And then what they do is they take it to their frontmen in Congress and they say, okay, all of us lawyers, our big team of lawyers, have gone ahead and put this entire bill together for you. Go ahead and present it in front of Congress. And they do. And then they get it voted on. And then those lobbying groups go to other Democrats and say, hey, we're going to give you money for your reelection campaign if you vote on this bill. They hedge it. It doesn't matter who's in charge, the far left or the far right. It doesn't matter. It wouldn't matter if this was a fascist country, communist country, a democracy. It doesn't matter.
I mean, it would matter a little bit if it was like a fascist country, because then you get like a Venezuela thing or a Maoist China thing where we're just going to go, okay, we're just nationalizing your business and you're not rich anymore.
As long as legislation is passed by people who are not in Congress writing it, right, and that's how all of it is passed, then the mega wealthy are never going to pay a dime in taxes. I don't know what this guy is talking about.
True.
Correct that the way to prevent yourself from having to pay high taxes is to aggressively fund the far right.
So just on that, he goes on about it a little bit more here, but
I would make this argument back.
Okay.
If it really was the case that the ultra wealthy were terrified of the left-wing elites and communists and socialists and things like that, why is it that the ultra wealthy allow them to be platformed everywhere and don't allow the far right to be platformed anywhere?
That's the point that I was making.
If it's really true that the greatest existential threat to the uber wealthy is that the left is going to tax away all day monies, then why the when they own all of the means of production when it comes to influencing
and newspapers and Twitter and blah 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 blah, why would they allow it?
Do they only ban right-wing content but not left-wing content? Makes you wonder which thing is really a threat to the system here, doesn't it?
Yeah, I mean, why do you think it is that right-wing content and right-wing ideas have gained such prominence on the internet in the last 10 years? Because this is the point that they're making. They're saying, well, they're funding all of these right-wing content creators and they have such big ecosystems, these right-wing content creators, and the left, they don't really have that. Cenk Uygur complains about this all the time. Oh, Young Turks are so small, Daily Wire are so big. Why do you think that has actually occurred?
No, it's really simple. It's counterculture politics, right? So what happens inside of the United States is every 20, 30 years, there's a big social revolution. Always a big social revolution. It has been the case for the last couple hundred years that most of these social revolutions have been progressive social revolutions. Just so happens that this time, the social revolution is moving the other direction. And it's because things have gotten so out of control that you have literal reading to 5-year-old kids and, like going to book clubs dressed as transsexuals, having kids stuff money in their G-strings, right? At that point, the counterculture is basically you against decadent Rome. And so, yeah, there's another social upheaval. It's about 30 years away from the last social upheaval. And this time it's moving over to the right.
What would be a social upheaval 30 years ago? It would be 1995. Was there a big... I mean, I guess you'd say Clinton. But yeah, was there a big social upheaval around Clinton? I don't remember hearing... I think I understand why he's saying 20, 30 years. That's just general cyclical politics. You know, like you have political correctness and these types of things. I think the nature of the sort of upheavals is a little bit broader than that. It tends to be like, I want to say it's like every like 4 generations. And a generation is usually like 20 to 30 years. So it's like, it's much closer to like, every 100 years, let's call it, something like that that tends to be the case. I don't think he's right in saying 20 to 30 years.
And this is just something that they haven't dealt with before. They haven't dealt with a social revolution the other direction.
That is true.
Right. All right. Well, here's the next clip.
I hate that
of
he
this
smokes.
fella.
I think so much of this growth in like the global right, the global far right, is downstream from, to be honest, you have to say it, a very, very successful online alt-right, far-right US. They've been so successful at that. You go online.
Yeah, do you know why though?
It becomes this.
Do you know why they were so successful?
Because the left.
They attracted a lot of normies. A lot of normal people were looking around at the world, and they said, all right, we've got two different sides. They're pitching us ideas. These ones seem to have been tried a little bit more, and these are the results that we're getting from them. This other side's pitching us something different. I don't know if I agree with them, but at the very least, they're pitching something different. So or they're pitching something that makes just intuitive sense.
Went completely insane.
Yeah, that's part of it, yes. But the main part of it was this. These lefties, they got greedy. They got themselves this bright idea. Lefties got together in about, this was between 2016 and 2018. And they decided that all right-wingers who talked about race, talked about IQ, talked about, interracial anything, talked about Jewish power, talked about Israel, talked about any issues other than status quo progressive issues were an existential threat to society, and therefore they needed to be removed forever and ever and ever from all social spaces. Well, what happened is they did that. YouTube went through, canned all of them. Canned every single one of them. Not only YouTube went through and canned them all, but all, right? It didn't matter where there was a platform. Doesn't matter if it was anywhere online that existed. Facebook, right? Any of these places, they literally just got rid of them and they depersoned them. And so this forced the right to do what? Create their own technologies, their own alternative banking systems, their own alternative infrastructure, so that they could fight back, right? That's what they did. So they started to make these little containment sites. Nick Fuentes had a containment site called Cozy TV. Gavin McGinnis has a containment site, which is Uncensored. Vox Day and Owen Benjamin created their own containment site. They all went and created their own containment sites, and they started working on these various technologies. So what happened when they started working on these various technologies is video processing got way better. Live streaming got way better. The ways for which to transfer money between people got way better.
I don't know if I agree with that. I'd have to see some evidence on that, because to be perfectly honest, all of those things are fraught with huge amounts of problems. Like, I'm pretty sure most of the people that he mentioned at some point in time were like targeted by payment processors. So like, way to transfer funds did not really improve. I think Twitch was already happening. These people got banned off Twitch. So I mean, the services of like, giving people money for live streaming and these types of things, I don't think it has anything to do with right wing, populism or anything like that. I mean, I guess there's like the idea of there's a little bit of extra competition, and that fuels some degree of advancement. But I think it's also just general sort of like, people could see the writing on the wall. Twitch was going to succeed, and therefore YouTube wanted to do it, and then Kick, and then other places. Like, Rumble is still, it exists. That's like the right-wing version of it, but it's still very much a little fish in a big pond.
And then along comes Rumble and says, well, we can take all of these disenfranchised people, and other alt platforms, by the way, we can take all these disenfranchised people and we can put them all on one platform and offer them our own payment processor, because now we're working outside the system. So the whole time these right-wingers were off these major platforms, they were still gathering large audiences. It's just that there was nobody to contest anything they said. There was not a single left-winger there to contest a thing that they said. They were completely uncontested in everything. And so it started picking up massive traction. Who was there to refute it? Nobody. And so now these guys they're like, what's going on? How is this happening? Well, what happened is when they accumulated this amount of influence and this amount of money, they were able to start making moves, and did. And now Elon Musk, you know, a billionaire who happens to be sympathetic to many of those causes, buys up X and says, you can say what you want here. Now you got mainstream Twitter is in the hands of the right. What they had already made an alternative of Twitter called Gab. They were already working on these alternative technologies long before Elon Musk came along and bought up Twitter and made it X. So the leftists did this to themselves. And so what was the rallying cry?
Now that's true. That part is true. I think everything that he said before that is like a shade of truth, but it's not really a good explanation for why there was the rise of these things. They're all true. I don't think they're a big actual factor in terms of like why the alt-right is a big giant online presence. I don't think that's true. And I'm actually not totally sure what the percentage is of like, you know, alt-right online media versus left-wing alt-right media. Like, okay, if we're looking at like the largest people out there, like Asmongold beats out Hassan. Yes, that's true, but Asmon's also very much like kind of centrist and non-political. He's kind of come around to being a little bit more conservative right-wing, but he's not like harping on politics 100% of the time. And most of his takes are, for lack of a better word, like they're normie. They're just kind of common sense takes that are going against sort of leftist or progressive ideology, but they're going alongside 80 to 90% of people. He is correct in saying, Andrew Wilson is correct in saying that the left did this to themselves. That's true. I would probably focus on the idea that, you know, the left, by depersoning people, it radicalizes those people. And especially when a lot of normal people get hit with this, when it's like, okay, you said some joke on Twitter and you got slammed over it. You got absolutely destroyed. You know, you lost a job. You had real legitimate, real world implications. You had real problems because of that. That makes people incredibly defensive and go, okay, well, what side was this person on? Because I'm going to be on whatever is the opposite side. Okay. Sounds like they are left wing. They've got a, you know, like a Ukraine flag in their bio. They've got pronouns in their bio, whatever. Okay. Whatever they hate, I'm going to do that. I'm going to be that person. They hate, you know, right wing people. I'm right wing all of a sudden. I don't have any idea what the conservative movement is about, but I'm that now. That is true. The left did it to itself. Yeah, I can say that's absolutely a factual statement.
Cry of the right, though, this is the major one. Why did all the right-wingers get so much credibility? Because they said, if what I'm saying is not true, they wouldn't have to silence me.
Yeah.
And that's a powerful, powerful argument.
It is. It's not necessarily true, but it is fantastically, just optically workable. It makes a lot of sense.
Yep. Yeah, and if they're saying, well, they're scared of me. If we would just debate, they know that they couldn't win the debate, and that is a very powerful argument. Whenever I see that, I always think, well, this person's got something to say, because if they don't want to debate them, if they're scared of them, then they must be onto something here. Mm-hmm. So, very powerful one. But it's like the left created the conditions for the right to have this ascendance online. They
forced it. They forced it. Imagine taking all of the voices of half of the nation, right? And just saying, well, they just don't have a platform now. There's no problem. And expecting that they're not going to make alternative. And the left demanded it, in fact. They were like, oh, yeah, go make your own alternative technology. Go make your own. These are private companies. They can do what they want. Go make your own. So the right goes and makes their own. And they're like, I can't believe that we allow in this country Nazis to have this kind of technology. And it's like, they did it to themselves. They did it to themselves. YouTube used to be a playground, man. 2016, 2017, 2018, you come on YouTube and you could talk about real issues. You could get really nitty and gritty. You could get right down into the crux of where it is you were going, and there was no penalty. It was truly an arena for sharing ideas in the political. But here's what happened there: leftists they made a convincing argument to get them deplatformed based on the fact that advertisers didn't like the boycotts that leftists were putting on for the anti-gay, Jewish, anti-whatever various alt-right lobbies that were coming in. But now they have their own technologies, they have their own audiences, they have their own funding, and they're a serious source of media. And now they have to deal with them. They're totally unprepared. They don't know the talking points. They don't know the arguments. They don't know the people they're going up against. They don't know anything. They're completely blind, and they've been blindsided. And they don't know what to do. And so what they've been trying to do for the last 2 years is say, just disengage, just disengage, just disengage. Okay, well, now Donald Trump's president. How did that disengagement work out for you, right? So now they have to actually engage, and they don't know what to do. They have no idea what to do.
Social space, right? And in this, like, especially this post-COVID age where people are online, people are lonely, that online US alt-right has done that. You go in there, and there's like 40, 45 different faces, and they bounce off each other and they beef each other. They're winning that space, man. I think it should be so obvious. It's so obvious that social media is becoming and will become more and more and more and more powerful in politics. And yet the political left has done nothing. And the political right is just...
Okay, I'm sure he's going to mention this, but they've done a lot. They've just not necessarily been successful because they're pushing a vastly more, extremist ideology that a lot of normal people don't agree with. And, it's not to say there aren't extreme personalities on the right. There absolutely are. But they're not successful in terms of like policy stuff. Like if you could look at like extremist progressive policy, a lot of that stuff is kind of trickling down into real world spaces. And therefore, people that are against it are like actually being threatened with it.
They can't
dominating that space. There's such an obvious shift in politics.
Yeah, they can't do anything, though. So the leftist policy, the official leftist policy for 10 years has been refuse to engage. Right? Leftist political streamer Hassan Piker refuses to engage. Bosch, right, got out of debates, refuses to engage. Destiny, to his credit, actually does engage, right? But he's one of the few who does. Almost no left-wing influencer will engage with any right-wing voices which are prominent. They refuse. And so you can't have a policy of non-engagement and then go, why are all these people taking over the space? It's because right-wingers go, bring it on, motherfucker. Well, let's go. You know what I mean? Let's debate. Let's have it out. Let's have these issues out. Let's look at these studies. Let's actually go, case by case, line by line. Let's duke it out. And they won't do it. And so they lose all of the very same spaces that they have. The second the playing field is evened out, the second they can't be like, he's a Nazi, get rid of him, and they know it. And so, yeah, this guy's right in a sense. It's just that they made the conditions for it. And by the way, this pussy, I bet you anything, he wouldn't engage either. Bet you anything, he has the same policy.
No, I mean, that's not true. He does. It's just he will be a real sophist. I mean, he had, what was it? He was on like the Diaries of a CEO podcast with a guy who was, I don't think right wing, but at least fiscally conservative. And he engaged, but he engaged very disingenuously. He was like a real kind of bad actor. He was making all kinds of just like nonstop debate moves, just sophistic arguments, not sophisticated, but, argues from sophistry, just trying to win people over, win the audience over by making them emotionally manipulated. I'm the hero. I'm the downtrodden. I'm the man of the people. I'm the underdog. I'm fighting a losing battle, and I have everyone else's best interest at heart. And it's not to say you don't. It's not to say you don't. No. Of course not. I'm not insulting you, even though I'm kind of insulting you because I'm being like very passive aggressively. I'm on the side of righteousness, and you're opposing me. Therefore, you must be on the side of evil. So he does engage, but he doesn't really engage as like an economist. He's not bringing up numbers and these types of things. And I get it. It's because, those numbers are not sexy. They don't make viral videos. Doing these types of quick, easy, man, the alt-right's going to be crazy online and all this kind of stuff. So the political left is screwing up and maybe I've got a solution. Those make better videos. They're just not good for like actually advancing the conversation in terms of a solution, in terms of something that would actually bring about a solution or a real, even like political conversation between different sides.
Refusal to engage with right-wing voices while he complains about how all the left-wingers are losing all of their spaces. How much you want to bet, Jake? I'll tell you what, DM this guy and tell him that you want to set up a debate with me. Watch him go, no way.
Yeah. He did do a debate recently-ish on Diary of a CEO, but I have no idea who it was against. I think it might have been, I don't know. But I'll DM him and I'll let you know how it goes.
Yeah,
Social
here's how
media.
it's going to go. DM him tonight, and tomorrow bring the receipts of him being like, no way.
Yeah.
No way.
All right.
The political parties are super slow in it. Do you know what I found out the other day? Nigel Farage has more
Does he have to be this close up to the mic to be doing this kind of stuff?
TikTok followers than the other 649 MPs combined. As simple as that. It's stupid, right? It's stupid. Like, what are these guys doing? What are they doing? Like, how blind do you not see? It's so obvious that politics is moving social media. And like, nobody's even moving into that space. It's insane. It's insane. There is, honestly, we are leaving so much food on the table here. We are leaving.
Yeah, I mean, the other side of it is also you have this big giant, legacy media thing, and legacy media is famously leaning left wing. They're much more friendly to liberal leftist politicians, and therefore, they don't want to move out of those spaces into the ones that might be a little bit more harsh on them, might give them less access, might give them less control. I mean, Kamala Harris doesn't go on Joe Rogan. Is Joe Rogan right wing? In terms of his politics, no, he's really not. But he is, at the very least, somewhat centrist. And that's kind of a big giant divergence from doing NBC, MSNBC, CNBC, CBS, CNN interviews or debates.
There's so much food on the table here. I honestly think this. The far right is only winning because there's nothing else there. There's nothing else there. Everybody hates Labour.
Well, okay,
Everybody hates
hang on, stop it there. In a sense, he's right, but he's mostly wrong, right? A kernel of truth for his propaganda to push it forward, but mostly wrong. He is right that there's nothing else there. But why isn't there anything else there? There's nothing else there because all progressives have to offer you is the status quo. It's more of the same. It's always just more of the same. But we need more gays, more feminists, more immigrants, more of the exact same shit that everybody's upset about. So everything everybody's upset about, the leftist is giving you a stamped guarantee that you're going to get more of that, right? That is their guarantee to you. And the right is saying, our guarantee to you is that we're not going to give you more of the same. You're going to get more of the thing that you, or less of the thing that you don't like instead. And that's a much more appealing policy, isn't it?
Yeah.
Conservatives, and I've been all around the world, and I could tell you the main two parties from basically any country. Everybody hates them. Everybody hates them. So the far right is winning because people are like, well, these guys are next. These guys are next. So look, we need to build something else. We need to build something else. You, me, the people in this room, we're not going to do it today.
They can't.
We're not going to do it tomorrow, but we need to build something else. And we need to build it not for us, but for the rest of the people. Something that they can understand.
They can't build something else. They're at the mercy. They thought that the tech nut giants were always going to hold monopolies on these tech industries, not realizing all it would ever take was one influential billionaire to break the monopoly. And we got two. We got Trump and Musk, right? And they broke the monopoly on these things. And so now suddenly it's like, well, wait a second, Facebook, you want serious regulations? Then go ahead and keep throwing people off the platform for just being right wing. And they're like, okay, hands off approach. YouTube trying to loosen up more of its TOS because they don't want to come under the gun either. Ultimately, the left created the conditionals for this problem themselves by refusing to engage. They put their head in the sand and thought.
I don't think it's refusing to engage, putting their heads in the sand. I do think that it was, a tactic of sort of, depersoning, dehumanizing, and ultimately making one side very attractive to anyone who's being alienated because they're also being alienated. And then also it does give a real legitimate optical message of these people are so dangerous. Like it is kind of a cool thing because it's like they're not being dangerous in a outwardly violent way. They must be dangerous intellectually. Okay, well, why are they dangerous intellectually? And I'm like, well, who are they dangerous towards? Well, I guess it must be the people in power they're dangerous to intellectually. I don't think I'm a person in power. If their ideas are dangerous to the people in power, maybe they help me. I should probably go look at them. I should check them out. And I think that's probably the real thing. Again, I do believe, he's right in saying, the left created this. It's not a good space to be in, but I don't know if we're trying to get out of it. I'm not sure. Alrighty. And with that, I will finally fire up Uma Musume. Taking long enough. It's going to be a minute until it gets loaded up, though. Ugh. So what's going on? How's everybody doing while this is rolling? I really need to... Well, I don't want to say I really need to, but I would like to at some point in time, relatively soon, maybe next week, maybe on my next break, Wednesdays and Thursdays, I'm going to try to make a better looking, overlay or something like that. I don't know if it really makes a big difference. It makes it look a little bit more professional, but I don't think it makes it look any different in terms of like real legitimate, oh my God, this person doesn't have a stream overlay. Though I will say the only thing that I'm wondering about and worried about is whether or not I'm going to be able to see like other people's stuff. If they give me some kind of like, okay, no, that worked. If they have some degree of... There we go. And... perfect. If I ever end up getting donations or something like that, I want to make sure I can... okay, are you kidding me? Come on. 9 should be pretty quick. Alright, let's see. So we've got, I think, like roughly an hour left before we're done. So we'll definitely be able to get our... Oh, damn! Okay. Glad I got that. 530 carats? That's huge, dude. Let's see what all these gifts are. Pretty good. Alright. Main thing we want to do is get our dailies in. That's not what I'm looking for. I don't remember any of these. Win a race in career, complete a career playthrough. Alright, let's do the daily races. We'll do you. I'm not gonna do you. I'll probably do you. Yeah, that's good. And then we'll try to get some career races out. I'm still, generally speaking, doing the... whatchamacallit. Whoa! 5th. I suck. Alright, let's go next. Let's go for the easier one. Yeah. Let's go for these easier ones. But yeah, I essentially just want to try to get this stuff knocked out. Use up my... Nah, we'll just do results. I hope this gives me... Does this give you your stuff? Let me see if it does. I hope that gives me my mission. It does. Good, and we need one more. One more. I don't know how to navigate to it, so we have to just click this. We'll do you. And we'll, at the very least, we're gonna try. We're going to try. Next. Race it. And we'll just hit these results. Oh, we got first. Alright, pretty good. Especially for horribly mismatched. Daily sale, let's see what we get. Just buy everything. Alright, are there anything I should be rolling for right now? I've got a decent amount of carrots, nothing crazy. The last thing that I was aware of was the Kitasan Black, which I did get, and I'm happy about. But I don't know if there's anything else I should be rolling for. Currently, I'm trying to get some... Let me see. No, I want to do the career stuff, at the very least get something. I don't know if we'll get to the end of this, to be honest.
何よ無理
All
な
right.
ことしてない
Let's see if we can get anything good out of this. No, not really. Let me see. What's our failure rate? 12%. It's not great. It's not
無理
terrible.
なんかしてないん
We
だ
got great.
ちょっと疲れただけよ
I'll train wits.
集中しなきゃ
Not ideal, but it gives me something.
あっぱれ
Nice, nice. Not too bad. Reporter Otanashi interviews me in preparation for the URA final. I don't know, we already saw this. How to pull out all the stops. Oh, yeah.
体が
Come on.
軽い
Let's see it.
今なら何でもで
5%. That's not too bad. All right. Who can we level? I think Guts. Stamina's pretty decent. I kind of do want to go for stamina. I want to get the Super Creek. 3%. Or you. This has more bonuses. I think we'll go stamina.
行くわよ
Success. Excellent. So we're going to have to...
あら
Are we done for the day? That's not enough. I need to be training way more. Huh. I'm shooting for number 1, not second place. I won't stop until I can outrace everyone. Running is as much about quality as quantity. You want to try to get the energy stuff.
そうね
Let me just do one more lap. I'll make sure it's the best lap I've ever done. That will be overdoing it, right? Iowa Scarlet runs the lap in her best time yet. She's finishing up, satisfied with her performance. Energy by 5. It's not good enough. Alright, several days after Iowa Scarlet's debut. My, would you look at that? Another special on Scarlet. It's just Scarlet and vodka everywhere I look. How about this for a scoop? The talented magical girl Sweepy is killing it in the big leagues. Now, don't go picking fights or I'll have to sound the gong. The gong? Oh, Scarlet.
ね
Hair. Look at this article, the future queens of racing. First place is vodka, and then next is you,
で
Scarlet.
も
Which makes me the runner-up.
あら
You look disappointed. I thought that would be quite an honor. Sorry, I shouldn't be talking like that in front of you. Don't worry about it. A refined princess is patient in all things. But you should take more pride in yourself. Many people would give a lot for what you have.
うーん
Great, now I feel like garbage, and it's all because of her. All because of who? Don't get the wrong idea. I would never say something so... Oh, it's just you. Jeez, don't scare me like that. Isn't it obvious, Vodka? Everyone just keeps going on and on about how great she is. She's so annoying. She's wrecking all my hard work. Why? What do you mean, why? She stole my #1 spot. Everyone sings your praises when you're #1. Like, wow, look at her. She's so cool, you know? When you get second place, it's all, well, you tried your best. You'll get it next time. I don't want pity. I want admiration. You're already #1 in my book, girl. So what? That's not what I'm looking to hear, dummy.
あのね
Good grief. What I'm trying to say is that I need you to be giving your all. Once I get placed in the first place in the classics, everyone will start looking at me differently. So I can't slack off while I'm still a junior.
絶対に
I'll train and train and train until I'm strong enough to snatch #1. And then
行くわよ
I'll blow them all away with beauty and grace in my first classic race. Nice. Get some bonuses from that. I think we kind of have to rest here. And we're also going to have to do some... What are we going to call it? I guess we're going to have to do some races to get more fans.
あーもう
Right?
気持ちに体がついてこないわなんだかほど
So let's rest.
あら
Just wait till you see how well I train today.
一番を譲る気なんてないわ
Okay. Stamina again? It's got 3, so let's try to hit it. Let's get that friendship up. Not ideal. I'd like to be doing some other. I'd like to be doing speed. But we're really trying to max our Really trying to max our friendship. I'm out in the shopping district when I see two familiar faces. Flower! Thank you for showing me where the greengrocer is. Yeah, happy to be of service. We've got a lot of work to do after all. Because sandwiches really are versatile food. Even the way the vegetables are cut can change their taste. I don't think that's true. What? I don't really understand what you just said, but I always like learning new things. Any other tips? What else do you know about cooking? A lot, I guess. But really, the key to cooking is, well, this is how I cook than a general rule. It's probably of no use to you. Nonsense! Please, I'd love to know. I'm the class representative after all. I love to learn anything and everything. Anything and everything, huh? Well, okay, it's really silly though. I always cook with love. Ho ho! I see. Your special ingredient is love, is it? Yes, I always try to make food people like. Food that always makes them happy and brings a smile to their face. I keep that in mind when I choose ingredients and when I start to cook. I think it makes everything taste even better. Oh, I see. I get it now. So what you're saying is good cooking makes people feel good. Makes them bakshin. It's got to have spirit in it. And I need to keep that in mind when choosing ingredients in cooking. Oh, yes, that's perfect. So how about we choose some ingredients that will make our friends feel good? Okay, then off to the confectionery shop we go. Aren't we making sandwiches? The ultimate feel-good, feel-bakshin food is, of course, sakura mochi, my family favorite. Come on, let's go. I know a great shop. Wait. Why don't we go and ask everyone first? Everyone has different preferences, you know. In some cases, there is something more important than speed. Eureka, I got an idea that's going to be useful. Excellent. Let's see what we get. Speed. Excellent. Okay, we needed the speed. We needed the speed bonus, man. I think we're probably going to be going for speed on this. Okay, yeah. Oh, that's so good. I think we will go for you just because it gives us way better friendship bonus. Friendship up. Oh, just as I finished telling Daiwa Scarlet to take a break during training. Hello there! You two are doing such a great job. Thanks. I think I've seen this one. Let me know if I can help with something. Don't be shy, you can ask me anything. Give me pointers? Would you like to train with us? What do we think? Yeah, let's see. Oh, I'd love to. Don't follow, let's try and get the dumbbells. Alrighty, good stuff, baby. Stamina and friendship. Excellent. Alrighty. Now, kinda, yeah. Good, I was gonna say. I kinda sorta shouldn't have done that. But it's okay. Okie dokie. Who are we getting? I really want to do it. I really want to do it because it gives me... I can't, though. I have to rest. I have to. That sucks. We missed it. We missed the rainbow. Terrible. Wait a minute, where did, oh, I guess she's gone. Definitely speed then. Hit it. That's our best, yeah. Okay, come on, here we go. Yes, thank you. For you. No, she's not as useful. Definitely go for Kita-san block. With this, hell yeah. Give me that big stuff. Friendship goes up, big time. Alright, and we get a bonus front runner straightaways. Excellent. That's what we're looking for. Because this is still super early, so we're really trying to max our friendship more than anything else. Ugh, what should I do? What's wrong? Can't stop thinking of this limited time. Become number 1, Super Stamina Beef Bowl. I mean, it has number 1 in its name. It's a match made in heaven. But it is a lot of food. It might be too heavy to eat right before a race. But I can't pass up on first place. Me of all people. I don't know what to do. Eat like a champion and become number 1. You're right. I'll eat and just burn it off. And if it helps me win, even better. That settles it. Let's see if this really makes me number 1. Oh, huge energy boost. I love it. Hell yeah. Huge energy boost. Do we want to go for Super Creek or do we want to go for Fine Motion? Fine Motion's kind of better. Wit. We can get power and stamina out of this. I feel like this is slightly better. Yeah. I'm gonna go for her. Yeah. So we can get some extra fine motion stuff, which, yeah, because she just does super good hint bonuses. They're really super powerful. Now that hits the spot. No lunch is complete without some melon soda ice in this one. Is this your first time trying melon soda? I have no idea what this does, though. Energy went down. Boo. Alright, I hope there's nothing. Ah, you son of... You had to do this, didn't you? You had to do that to me. I have to rest, though. A model student is always early to bed and early to rise. I got my beauty sleep last night, now my skin is flawless. Meanwhile, someone can't stop yawning. Did you stay up too late? I was working on our training program, you ungrateful so-and-so. Oh, I see. Then it's an early night for you tonight. You hear? Can't have you collapsing on me. You son of... I'll kill you. It's finally time to experience the #1 view. Come on, trainer, there's no time to waste. Let's ride the roller coaster. I can't wait. Me neither. I can't believe this theme park is such an exciting ride. I was skeptical when you said you wanted to give me a reward for all my hard work. But I couldn't say no to getting a taste of being in the highest spot in Japan. Now let's get up there. What's with this huge line? A long line snakes all the way to the roller coaster's entrance. The ride schedule says the wait time will be 200 minutes? That can't be right. And we have to stand the whole time? I came here to take a break, not to get even more tired. But we can't all this way. What should we do? Let's ride something else? What do we think? Yeah, ride something else? Or are you giving up on the #1 view? Personally, I ride something else, right? Yeah, let's ride something else. You're right. Everyone's lined up for this, so I bet the other rides are empty. Alright, times like this, you just take another path, #1. Ooh, so dizzy, you spun that teacup way too fast. Though we were definitely #1 at spinning our cup. Yeah. You should have seen our face, trying so hard. Laughing makes me feel even dizzier. But with this, we're now #1 at almost all of the rides. We were #1 at the shooting gallery. We set a new record on the go-karts. Let's see what else. I think we're #1 at enjoying the park today. You bet, baby. That sounds ridiculous. But come to think of it, I really did have a lot of fun today. Anyway, it's getting late. We've still got a lot to do tomorrow, so let's head back. I've got my sights set on being #1 in the next race after all. Being #1 with Die with Scarlet today has been a lot of fun. Stamina by 10? Heck yeah. I'll take that. I think I need... Yeah, let's do a race. Let's do a race real quick so we can get our fans. That should do it. Itching to get started. I'm ready to race. I'm ready to win. I can't wait. That's the Die with Scarlet I know. Yeah, and that's my trainer. The audience, my rivals, I'll show them all who's #1 in speed. Power by 5. I'll take it. Alright, she's 100%. It's a blowout. Was I running it front? I guess that's her only pace. I didn't even look. I should have looked, but it doesn't really matter because I'm so super blown out overstated, I'm guessing. Hopefully, we could see an absolute, complete, total, absolute annihilation here at the Sendyu Show. We got a beautiful blue skies here at the Hanshin Racecourse. The turf should be nice and firm for today's race. It should be a good race to show her true strength. For the third favorite, we have Ontologist. She might not be satisfied with this ranking, but the second favorite is Taiki Shuttle. Carrying the hopes of all the fans crowding the stands, my favorite for today is Daiwa Scarlet. I just hope the Uma Musume I'm rooting for gives it her all today. They're all in line. We're ready for the start. Man. Alright, the race begins. Great start from all runners. She's out in front. That's good. Battling for the leader, Daiwa Scarlet, Lady Adamant, and Taiki Shuttle. Daiwa Scarlet is flying ahead with ease. Now Daiwa Scarlet is taking the lead, but can she keep it? I think so. Eyeing up the lead from second position is Lady Adamant. Taiki Shuttle is in third. A little behind her is Reckless Shot. Directly behind her is Encore One More. Passing on the outside is Karn went on. Ruben Benuit closes in, closing up slightly behind is Powerful Torque. Watching from behind is Kutawi. Too Nice Way is something. To see the outside is Breeze Cessna. Moving along the outside is Excited Stuff. Just on the inside is Tropical Sky. Right next to her is Malika. Venbol is right behind. Then Ontologist. Next to last is Nautical Tool. Raven Relay starts the race in last place. And then we gotta blow it. Alright, coming up with the fourth corner, here comes last spurt. The race is really heating up now. The race for the decided on the final stretch. They're clustered together. It's a free-for-all. It might be a little confusing with all of them packed together like this. Daiwa Scarlet pushes forward. Wow, who will make their move first? Taiki Shuttle stays in second, keeping a close eye on the situation. We'll test these two to the wire. In front is Daiwa Scarlet, but she's only got a slight lead. But I did get an activation, so here comes the hill, and Nigawa's slope starts here, keeping the lead with Daiwa Scarlet. Pulling ahead is Daiwa Scarlet, but the others are close behind. 200 meters left. Daiwa Scarlet pushes even further ahead. Running with all her might is Daiwa Scarlet. Widening the lead is Daiwa Scarlet. Okay. Daiwa Scarlet finishes. Daiwa Scarlet wins, baby. That's the good stuff. Heck yeah. Let's see it. Number one. Good stuff. Alrighty. Next. Alrighty. That's pretty good. What a spectacular victory. It's all thanks to her hard work. Now I'm certain the next extra large full color special feature has to be about you two. Sounds like we can expect a great response from the next Twinkle Monthly. I got to praise Daiwa Scarlet for her victory. Energy down by 15, mood remains great, power went up by 5, skill by 35, 500 fans. Friendship with Etsuko Otonashi went up by 15. I feel like I should have gotten way more fans. It's New Year's, and I'm in my office, and I should have gone with less energy, whatever. I knew it. I saw the light on, so I figured you'd be here. Anyway, Happy New Year. May the New Year bring you peace, joy, happiness, and all that. How thoughtful of you. Come on, it's just the standard New Year's greeting. Don't get to work up. Oh, and here. A New Year's card. You're my trainer after all. That's for all you do and stuff. Whew. You wrote a card and everything? What are you getting excited about this? This is pretty standard, you know. Well, whatever. That's it for the pleasantries. Now let's get to work. Yes. I want to take on the classics this year, so we can't afford to slack off. Okie dokie. We need to come up with a strategy. We need to collect data. I don't really want to skimp on rest and lose this because my energy's pretty much already full. Let's come up with a strategy, baby. Exactly. After I'm finished with my training, let's start scoping out the competition. The year's only just started, and there's already so much to do. I really can't afford to slouch around. The year has barely begun, but Daiwa Scarlet and I have already started preparing for our next race. Wit by 10, that's pretty good. Alrighty, let's check it, baby. Alex O'Connor looks different here. We've passed that. We already did that. I understand, Joel. It is a little bit different, but I feel like this is roughly what Alex O'Connor would look like if he was an anime Horsegirl. Right? What do you think? You think he looked different? Let's see. Any really good things here? You know what? Stamina looks pretty good. Yeah, let's get that. Okay, we got both of these guys greened. Alright, one day during training. We've already seen this. Skip. Speed. Absolutely speed, baby. Speed all day. Nothing but speed. Speed again. 0% failure rate. Hell yeah. Identical, just missing the mustache. Pretty much. All right. We're getting some good extra bonuses here. I want to see if I can do... We are just going to do wits training. For nothing else, we can at least... Let's see, 5%. Stamina is not bad. Oh no, power. Guts is pretty good. I don't want to do anything with a failure rate, so we're just going to do this. That gives us something. I'm happy with that. Our speed should be way out in front. We should be completely, absolutely annihilated here. Yeah, good stuff, baby. Okay, cool. We got our good wits up. And this does get me right to the thing. That's what I thought. All right. One day while I'm walking around the school grounds, crash bang. I'm so sorry. Are you okay? Kita-san Black bumps into me and drops her belongings, scattering her stuff everywhere. So I go to pick it all up. Cooling patches. Kita, did you drop this cold medicine? And this vitamin drink. Are you feeling sick, Kita? Oh, that's stuff for Dia, not for me. I'm heading to visit her in the infirmary. She's a race soon, so it's the worst timing. I know snacks won't help her much, but I can't just sit by and do nothing. How sweet of you. Sports drinks will help too. Here, have one. Oh, are you sure? Take this apple compote too. I was just about to give you some anyway. Okay, what's the difference between compote and, like, jelly? It's made from the apples you helped me carry home the other day. Oh, I remember that. Thank you so much. I'm sure she'll love this. Hey, take this too. Just a little thank you from Golshi. Oh, there you are, Kita. I found that thing you wanted. This is so much. Are you sure? Well, Nishishi, you're always helping me out. It's about time I paid you back. Let me help you carry all that. Thank you so much, everyone. Okay, I'm here, Dia. Are you awake? How are you feeling? I'll put the get well soon gifts over here. Kita, thanks for coming. Achoo! You okay? Feeling chilly? I bought you the cold medicine you usually take. Everyone sent along some tasty food, so eat up, drink up, and rest up, okay? Sorry about all this, Kita. You really went out of your way for me. What are you talking about? I'm doing this because I want to. You have a race coming up, remember? I wanted to leave you in the dust. But there's no point if I don't beat you fair and square. I won't accept the win unless you're in tip-top shape. Kita. See, I've got my own reasons too, so just rest up and let me handle this. Guess you'd better get well soon. Bounce back even better than before. Yeah, baby. Of course, I won't let Kid outshine me. I'll eat my fill and get plenty of rest. Then I'll feel even better than before. Gotcha. Okay. Satono Diamond has just entered the gate and she's aiming for a full recovery. Apple compote, carrot porridge, cold medicine, I'm all set. Will sheer good health be enough for her to outrun Kita-san Black? The race to find out is about to begin. Laughter and delicious smells fill the sunset-lit infirmary. We've got an idea. Oh, speed, hell yeah. And 3 hint levels for straightaway adept? Oh, that's blown out. That's a blowout, baby. Hell yeah. Alright. Alright. So here in the chat, anyone can tell me, what are the skills I should be going for? I've heard these ones, the gold ones. I kind of feel like that's true. I feel like these are better. And the fact that they're higher priced also means they're probably better, right? This is almost certainly my best value for money because I have hint level 3, which is insane. Or this. Slightly increase velocity on a straight. That's pretty good. I don't think I could do both. I feel like I want to hit this guy. Slightly increase velocity on... You know what? Because this is just totally non-conditional. Yeah, this is just totally non-conditional. as opposed to front runner. Yeah, I think that's better because I might need to run like pace some other time. So I'm gonna hit that. New skills, 57. I don't think I can get any other ones. All right, let's race it. This should be pretty well good in terms of like, I should be able to hit it. Okay, I finished changing and my legs feel ready to race. The only thing left is to take home the Tulip Show. You look like you're ready to go. But of course, I'll tell everyone why I'm going to be the #1 favorite this year's Tiara Tour. You gonna be what now? Vodka. I heard someone yelling about being #1, so I figured it was you. Hate to break it to you, Miss Model Student, but this race is mine. Well, look who showed up uninvited, just to mouth off. Save your breath for the race, because you're going down this time. I'll have you running home in disgrace. Say what? You trying to pick a fight? What are you upset about? You're the one who came out swinging. Calm down. The race is about to start. Ugh, what is with her? Her strength plays towards the Tiara Tour races, so I figured she might show up, but go prove her wrong. Like, I need you to tell me that. I'm going to wipe the floor with her. This is the start of my Tiara Tour. I'll show them all who's really #1. Alrighty, we are #2 favorite. What? I mean, who's #1? Who is #1? Oh, okay. So we probably are going to lose this, but I think we're supposed to lose this, like, scripted. Because we're only supposed to... The only thing that we need to do to win this is place in the top 5. So I think we're pretty solid here. My guess is we're not going to win #1. Because we're not supposed to. G2, baby. Let's hit it. Tulip Show. Next. Alright, we got gray skies for Hanshin Racecourse. The weather is still holding out, though, and the track is firm. I hope the weather holds out for us. The current favorite is Vodka. Third favorite is Marzenski. The second favorite, Dawa Scarlet. Should give us a showdown to remember. Let's hope for dead heat. That's when the sparks fly. They're all in line. We're ready for the start. Bang. Alright, there's the start. A wonderful start from all runners. They all seem to be in the zone. This should be a good race. Uh-oh, we're #2 already? We should be front running it. Can the favorite Vodka live up to everyone's expectations? She's running last, like pace, whatever it is. So, to be honest, we're kind of really super duper. It's not going to matter any time. You know? I would say, you know, look, keep a good bunch in reserve here. We don't want to be doing crazy. Vodka is our main competition here. She is way in the back. Yeah, she's way in the back. She's going to make her move at the very last minute. So to be honest, we want to really keep, you know, some degree of pace. But I gotta be honest, I'm surprised we're still in second. We haven't hit #1. Alright, pulling ahead is Marzenski. The others are close behind. Coming out of the final turn, first is Marzenski. Yep, fight for second. Dawa Scarlet, Nishina Flower. Wait a minute, is this not? Are we waiting? Still going. Still going. Okay. Red Ace. Alright, very nice. And there we go. Okay. I think... Oh, man. We had like a dark horse almost take it. Alright. Yeah, Nishina Flower really pulled it out. She came out of nowhere. Dude. She came out of freaking nowhere. I thought for sure Vodka was going to be coming up, but nope. Dude, that's crazy. I'll take it. Next. Let's see it. That was ridiculous. Ooh, were you watching? Did you see how I sprinted across the finish line in first place? I knew you'd do great. Of course, there's no way I'd let someone like Vodka get the best of me. But I'm not letting up. I'm going to get first in the next race as well. Even in the Oka show, huh? Absolutely. The first hurdle of the Triple Tiara? I'll leap right over it. Alright, no time to rest. This is just the beginning of my career as number 1. Speed. Yeah, we get bonuses everywhere, which I'm happy with. Top 5. Pretty good. These are all like just top 5s. The only first places are the last ones? That's interesting. Alright. And we've seen this one before. Cool. 1 turn to reach goal. Yeesh. Ruh-roh. I'm gonna save and exit. Because I actually want to try to do some, with the what? 20 minutes or so left. Collect these. Got it. And we can do you. Team trial's not bad. Class promotion. Okay. Congratulations on making to class 2. More team slots unlocked. Okay. I don't have any, but that's cool. I don't. I've got like none of these things. Okay. Her. Do I have a better version of her? No, I don't. Okay. That's fine. Let's team race. Whoever's the weakest, let's give it a shot. Race it. Shinshimashou! Alrighty. See results. Lidoink. Oh my god, I lost? Ruh-roh. Losed again. Oh my god, I suck. I definitely need to win that. Alright, let's see. Draw. Not ideal. Okay, and draw again. So I think we kind of lost there. We lost. Yup. No. Oh well. We got something out of it. Who cares? We got a sale out of it. I'll take it. Just spend all of this free money. I don't even know what any of these items do. Right now, I've got no clue. I'm sure they'll be useful eventually. And I'll need to buy them, so I'll buy them for, you know, sale price. Keep getting, like, all of this free crap. And you. Nice. Home. Whoa. Okay. Is there anything I should be pulling for? I don't have a ton of time to do it. But it's okay. Alright. We're almost... Ooh. Oh, that's right. That's why I wasn't able to do this. Because we were trying to find... That's right. That's right. That's why we were doing Die with Scarlet. Because we were trying to build her out so I could actually do that. Okay, where is this free? This one? Okay, I'll take it. It's free. Let's see what we get. Anything good? Nah. That's fine. I'm okay with it. Alright, anything else that's free in here? No, no. I know we've got this, the make debut. Is this it? No. No. Featured cards. Yeah, this is what we're getting. We're getting the support cards. We're not getting the actual Umas. That's what I'm looking for, because I don't have any... I never pulled any Umas. Whatever. We can go a little bit further into this. Let's see what happens here. Train. Stamina. Guts is not bad. I'm gonna go stamina. Try to get Super Freak. Because she's pretty good with stamina. I don't need it, but it's okay. And then stamina training leveled up. That's good. That's what I wanted. Training's done. Time to get back and do some homework. What was that? Is someone calling me? The 3 goddesses statue. Inspiration! Huge, baby. Let's see it. Go! Inspiration strikes. Inspired by vodka. Power spark activated. Inspired by rice shower. Stamina spark activated. Pace chaser spark activated. Inspired by Sakura Shino. Speed spark activated. Inspired by Major McQueen. Stamina spark. Pace chaser aptitude went up. What the? Am I back? I was surrounded by light. It felt so warm. Now I feel like I'm overflowing with energy. Alrighty, baby. What is this bronze? Okay. I think I should be able to get one other thing. Yeah. Do it, baby. Hell yeah. Especially because frontrunner's where she wants to be anyway. So I will take it. Absolutely. Now this is the one. Maybe this is the one I lose. The day's finally here, folks. The first of the Triple Tiara races. Which of today's racers will claim the Sakura laurels and ascend the stairs to the Queen's throne? We saw sparks fly between Vodka and Daiwa Scarlet during the Tulip Show. We really didn't. Vodka was back of the pack. Daiwa Scarlet was out in front the whole time. And it might well happen again today. This will be a showdown between the 2 rising stars of the Tiara Tour. It's a race you won't want to miss. Feeling nervous? Of course not. If anything, I'm excited. Once I win this race, I'll be that much closer to the top. Not to mention she's running in this race too. Who's she? Vodka, obviously. Just to be clear though, I don't care about her at all. Of course not. The first tiara has my name on it. I'm going to be number 1. Well then, time to take the throne. Alrighty, we are number 2 favorite. Ooh, interesting. Turf, front, aptitude, mile, we're good. Let's race. Let's race, baby. I do wonder how much this is actually like our G1. The cherry blossoms bloom, waiting for the crowning of our next queen. This is the first race of the classics, the Oka Show. The most popular athlete in this race is Vodka. She's the favorite to win. For the third favorite, we have Grass Wonder. Now here's the second favorite, Daiwa Scarlet, who's fully set on clinching victory. What a presence, look at that spirit. All the Uranus may have entered the gate and are ready to start. Beep bong bong. Bing. They're off. A great start from all runners. They all seem to be in the zone. Oh man, somebody really took the lead here. Who is like way out? Is that? It's not. Is it Daiwa Scarlet? Okay, she's in front. All out there by herself. Eyeing up the lead from second position is Hunalpu. Slightly behind her is Breeze Plane. Fourth is Tactical One. A little behind her, Tactical Flower. On the outside is National Flower. Sticking to the inside is Blue Chocho. 2 to 3 lengths away is Grass Wonder. And then Kaiser Palace. Coming from the inside is It's Calling. Moving from even farther out is Vodka. Multi-Cell Call closes in. Just on the outside is Tudor Gordon. Then Ribbon Etude. Requiem Wisp. West Grimoire. Moving from the 4th corner into the final stretch. Here comes the last spurt. This race is really heating up now. Breeze Plane pulls ahead here. They're saving their stamina for the end. Will this race be decided on the final stretch? And keeping an eye on the floor. Red Ace! Daiwa Scarlet pushes forward. The Vodka remains held back. And keeping an eye on the leader from the inside is Breeze Plane. Vodka's charging up the outside. Look at Daiwa Scarlet 1. Coming out of the final turn first is Daiwa Scarlet. Straight away at it. We're getting some good activations here. It's Daiwa Scarlet. Daiwa Scarlet's in the lead. 1/10 run. Alright. We're doing really good here. Still in the lead is Daiwa Scarlet. Alright, Daiwa Scarlet lead by 2 lengths. Still looking good. Unless someone sneaks behind us. Okay, we're good. That's the bigness. Oh, ho, ho. Huge victory. Yeah, baby. Number 1. I think that means we get a concert. I think that means we get it because that was the first time she won a G1. I think that means we get a concert. Hell yeah, baby. It sure does. Move me. That's a big statement. All right, we're getting better than that. That's a pretty good end. Right? That's got to be a pretty good end point. Ending up on a first G1 and a concert, I'm very happy to say thank you very much for all your time and attention. Good luck in all of your endeavors. And for now, I shall say farewell. And then I'll click on stop streaming.